And so, like I said, the goal today is to be, I want to show you what it's like to set up the virtual machines in the background because there's more that goes on to it than most people realize. Um, it all depends on how you want to deploy it, how you want to test it. The goal is that you can use these kind of things to either train student organizations, your students in the classroom, and then maybe you can start writing your own. But from the get-go, what I would like to do is come out here to that Vuln Hub that I mentioned to you guys before. Again, this is kind of like a repository of vulnerable virtual machines that somebody has already set up a scenario of some sort. All right. And we can learn a lot from these, and we learn a lot both from how some people design these. We can also learn what's all needed to make these work. And then it really helps us build our own. And then if we build our own, then we can actually, build that in with CTF as well, so that we can bury some flags, give students challenges, use it as an exam in the class. We can use it as a final exam, all sorts of stuff. Worst case, you just throw it up and let the students attack it, right? Most of us are all in the academia space. We know that if there's something available, the really good students will start attacking it, and that's a good thing. That shows you who's there to actually learn, who's trying to apply themselves, and everything else. So, let's see here. Anybody else that I missed? In Gary's not quite here yet. I think he was the last one. Okay, great. So what I did was just a little bit of searching through all these VMs, and I decided to start out with something like PLC. And this one is like an ARM lab environment, really has nothing to do with PLC, so I'm not sure why they triggered that one. So then I thought, all right, well, let's go back and see if we can find any OT ones that just so happen to be out here. And it turns out, if we do a SCADA search, that somebody built one that mimics a gas tank system with the SCADA focus. No idea what this VM is. I wanted to play with that today, and show you how we can pull some stuff down that's already out there. And let's build an environment, see if it's any good. If we like it, great. If not, all right, we at least know how to go take a VM from here and actually deploy it so we can use it. Most of the VMs that you're going to see out here are either going to be VirtualBox or VMware, like you could use on VMware Workstation, that kind of thing. I'm going to show you how to deploy it on Proxmox, but just know that you could put this in VirtualBox. You could put this on a couple different places. VirtualBox, if you're just playing with it, would probably be the better choice. Proxmox would be better if you're looking to host it for students, right? That way you're not spinning it up on your laptop and then just sitting in the room and having to, hand out IPs and all that kind of stuff. So, long term for like my side is I would want to build this out on a Proxmox server, kind of get it dev and tested, and then I would put it behind like a NetLab system just so that it has a scheduler and it has the niceties of resetting the lab environment so that when any student schedules the lab environment, it's set up and ready to go for them. And then when they're done, they shut down and it reverts everything back so that it's ready for the next student. So that's really the benefit of like a NetLab system. You could absolutely do that in the classroom without a NetLab system. You just have to administratively do the resets and everything else. But I'm going to show you in a way that it's ready for that. And so you guys can utilize it off a small little Proxmox server. And again, we talked about these the other day. You don't need $1,000 systems for this. You can get started with a small one with a decent amount of RAM, like an old laptop or an old Optiplex desktop laying around, somebody that e-wasted one, something like that. And you can at least get a small CTF or a small vulnerable virtual machines up and running for them. Obviously, you want to take a little care when you're grabbing some of these images. You probably don't want to just light them up on your network. You want to make sure that they are in that sandbox environment because by nature, these are set up with vulnerabilities, right? So if you accidentally hook it up to the campus network, you're probably going to get some emails saying, hey, this has such and such vulnerability. Well, yeah, we know that. That's why it's there. So really building out that sandbox environment is a great idea. Yeah, Workstation's a great tool. Trust me, I was a huge VMware fan, obviously, for the last 15 years because it's been essentially free for my side working with them as an academic partner. And then when they took all that licensing away, it was rough. Now they made Workstation free. and they quote made ESXi free again. I'm just not putting any weight behind that because if you've
No
seen
faith.
anything that's gone on with those environments right now, they don't care about contracts, they don't care about agreements, etc. So, all right. And VirtualBox, I played with it. It's very limited on my side, and again, because I had stuff like VMware Workstation for that. There you go, Ken. I want to make sure I get you marked in there. I saw you jump in. All right. Um, And so I could download and install VirtualBox and kind of show you a little bit of what you could use there. A lot of things will kind of convert over to Proxmox as a server infrastructure. You just have to export it just right in order to make some of that work. Thankfully, the VMs that they have in here aren't too bad. We most of the time they give you it in an OVF, which is an open virtualization format. Proxmox has the ability to import that in with relative ease. I've tested this one just to make sure. Other times you got to do a little bit of conversion, a little bit of command line. It's not as clean as it was on ESXi for a lot of that stuff, but it can certainly be done. So to get started here, again off the good old Summer Connections website, I did create one for, if I can remember, I did it Vuln down here at the bottom, and I don't know why I called it Vuln Hub, but it should be just Vuln. Patch that real quick. I was typing in a hurry. There we go. So I put a little description up here, and again, I found this sample one from Bazaar. So we're going to go through what it would take to get this one up and going. Again, if you have a Proxmox environment, you're welcome to follow along here. Otherwise, it'll be recorded. It'll be very, very similar as to what you would do from a VirtualBox. So is there anybody that wanted to follow along with VirtualBox for this side? Terry? Okay, great. And then let's see, at least I'm assuming JB and Ravi, you guys have Proxmox systems that you want to follow along with, right?
Almost.
Okay. Okay,
I
great.
know Proxmox running on a box. As I said, that's an Optiplex right there.
Okay.
So
Okay. And then for the rest of you, are you okay following along? So like Debbie, I'm going to try to get this converted over to Docker containers so that you can deploy it there as a test. Well,
That was
that
my next question. Can you get it to a Docker container eventually so we can use that? But go ahead.
Yeah. I'll try to get them moved over to a Docker container to move. Just know there's some limitations on the Docker container side, right? Because you're relying on the host in order for Docker to work. Um, they're not individual VMs. Does that make sense?
Yes.
Okay. Okay. So we're gonna try it. I'm honestly some of this I've never pushed over to Docker in that regard, but it would be great if it works because then if I host those, you guys will end up with like the one-liner again that you just plug in and all of a sudden it pulls down the VM. So I'll do
On
my
the
best to see that.
on the Proxmox server,
Uh-huh.
what do we have to run as far as Docker on that server for the Docker files to work?
If you wanted Docker to run on there, then you would just need a VM, like an Ubuntu server VM, for example, and install Docker on that. And then from there, you could use it as a Docker setup, very similar to Docker Desktop.
So
Um,
you would run a virtualization on the Proxmox in order to run Ubuntu and Docker on the VM.
yes, yeah, and we're going
Okay.
to end up setting up some of those VMs here in order for this environment to work. So you would come in here with one of your hosts, and you would deploy some kind of VM, more likely like Ubuntu server for ease of use. You could deploy that here, and then you would install Docker on it. And then from the command line, you can run Docker start and all of that, and it would automatically start spitting up those. Um, like I mentioned yesterday, you could use Portainer if you wanted a bigger, nicer UI, that kind of stuff. But I don't want to go too far off in the weeds. There's lots of options there. The good news is if I get this to where I can distribute it, then there could be a VM that you pull down that already has Docker set up, already has the virtual machine set up. You just have to turn on the ones you want. Like that would be one end goal that I could come up with. It would be relatively simple and not break any licensing, that kind of stuff. For the sake of licensing and things like that, I'm going to steer away from Windows for now. Just know that Windows is obviously seen in the cybersecurity environment as well as the OT environment. But there's a little bit of headache on the licensing side. It can be done. It just takes a little more requirements. A lot of what I'm going to show here is quote unquote the rough way to do it. And it's the easiest way to do it that you could even teach students on how to do this so that they could set up their own training lab environments. There are certainly tools that would make this process simpler. And that's really what that project or product that I was trying to work towards called Forge CTF, which is really just that. It's going to do everything we're doing here. It's just scripted and automated. That's it. So to get started, when we look at this one here from VulnHub, we can go ahead and download this file. So if we go ahead and click on this link, this is going to give us a zip file with the virtual machine that we know is vulnerable. So again, just pay attention where you're putting it. It's not necessarily a virus or anything like that, but you want to go ahead and download it. And I've downloaded that here. It is a zip file. And then once you get it open, you can go ahead and extract the files inside of there. So I'll give everybody a little bit to get that down for those that are actually following along. And in the end, you should end up with these two files. And now all the VMs in here are going to be a little bit different depending on how they created it and what platform they created it for. Again, with Proxmox kind of being the next big thing for me, I'm going to start distributing a lot of this kind of stuff out for Proxmox. The other good thing on the Proxmox side, like I said, I distribute VMs. If you come into, like, say, your host, you get your Proxmox host set up, and you would come in here to your data center and to storage, and you could add a new Proxmox backup server. Generally, this is where you would have a Proxmox backup server to back up your VMs. However, it can work really well as a VM distribution system. So if you guys stay in contact with me on Discord and that kind of thing, my goal is that I'll get you an account on my distribution system for those VMs, and then you can easily pull those VMs straight into your Proxmox environment. You don't have to go to a website and download them, then upload them to the Proxmox server, make sure they're all configured right. You can simply connect to a PBS like this one, for example. And then when you come down over here and click on it, you can go to backups. And these are all VMs that are available for you to pull down, kind of thing. So that's a system that we use at NDG in order to distribute all the virtual machines now out to the individual schools. And it's proven just even during beta here that is a much better way to go. In the old days, we used to send out OVA files, OVF files. They required a whole different distribution method of a website and usernames and passwords, and it was a chaotic way of doing that. Now it's baked right into the back-end environment that you're going to be using. So I'd like to keep that. Makes it much, much easier for you guys as instructors. Yeah. Yeah. So here again, I have 3 hosts here in a cluster. You do not absolutely need that at all. This is again designed for a NetLab backend, but you can have a single host, single node cluster. That's perfectly fine for doing this part. So with those instructions that are out here, again, we want to download that. You guys should end up with 2 files here. It's a little bit more of a process to do things again on Proxmox, but we can absolutely get it done. So the first thing we want to do is get it downloaded, and then you want to upload these files to the Proxmox server. Unfortunately, they don't have a way in the GUI just yet, but Proxmox is making leaps and bounds on getting this stuff moved over. So for now, the best way to do it is to SSH into your host, or in my case, I'm just going to use the FileZilla client. And I put the links out there for that. And so I'm just going to treat my Proxmox host as a very simple SFTP server, right? I'm just using SSH kind of thing. So I'm going to connect over there. And if all goes well, we should have it connected over on this side, right? Hey, Wendy. Yeah, that's no problem at all. No problem at all. Again, this stuff should be recorded, so if you need a reference back, that shouldn't be a problem. All right. So on Proxmox systems, typically you're going to have things in var, lib, and I remember where it goes on from here. PVE is actually where it's at. This is where your basic install stuff would go. In a NetLab environment, if it's all set up, we just mount an external drive, or in this case, like an NVMe drive. And so the directory structure you're going to see for me is mount PVE NetLab 1. That's my first disk that I have available in this system. So if we look at my host and look at my disks, I've got the install system here. This is just for the basic operating system. And then I have a second drive in there that's meant for hosting virtual machines and things like that. So when this is all set up and mounted, the process that I use to do that would match there. If you absolutely wanted to, because it would not hurt even if you do not have a NetLab system, if you chose, I'll send that straight to Wendy. Sorry about that. I sent you a link to the NetLab documentation site. And again, this is if you were a NetLab customer and that kind of thing. But the good news is if you just need instructions on getting Proxmox up and going for something that would be compatible here, you could easily go out to the Proxmox environment and Proxmox installation. And it has a nice little guide here that's going to walk you through how to set up your environment so that it would match a NetLab system, which would then match all my documentation. But all this I've already documented and kind of put out here. Easier to follow up. So, okay. You have, again, you don't have to do it that way, but if you're trying to match what I'm doing here, that's why. So my goal is to come in here, and what we want to do in this directory structure, you'll see the dump, the images, import, snippets, templates, etc. We want to create a new folder called OVF import. All right. And then inside OVF import, we can go ahead and just grab these two files and transfer them across. And so these aren't too terribly big. Looks to me like we got just shy of a gig for the disk that's in there. And you'll note that disk is a VMDK. So it was originally written for like VMware Workstation, but you could obviously import this into VirtualBox and Proxmox here as well. So with that up there, let me pull back up the website. And so we've got that transferred over. Now we just need to open up a shell on our Proxmox server so that we can run the import command. Again, unfortunately, there's not a UI way of doing that. So we just copy and paste this line if you matched up with the right things, or you could change it. When you do these kind of commands in the shell on Proxmox, you're asking to give it a VM ID. And if you're not familiar with Proxmox, everything's kind of centered around a VM ID. You can kind of see this over here. So I have some VMs that all have different IDs. The IDs have to be unique. In other words, you can't have two VMs with the same ID. You can have two VMs with the same name, which is a chaotic thing because in VMware, you never had that, right? But in Proxmox, you can have the same name, you just can't have the same ID. So the reason I mentioned that is if you run this command multiple times and it complains there's the same ID, that's why.
Yesterday, you guys mentioned a couple of devices that a Proxmox would run well off of. At some point, could you remind me what those were? But you can get back to what this was. But
yeah. Let me put a note down here. As a matter of fact, in the first break, remind me, and I'll pull them back up.
Yeah, I mean, I can watch back the video, but I'll ask you in a second.
Yeah. And again, I haven't fully tested on those, but I will test them, like possibly even tonight, and see if I can't make sure that they're there. Now, the MSO ones I know work because that's the environment we're playing on. But those little $120 boxes should work with Proxmox with no issues, at least as a starter setup kind of thing.
That's where I would start. So yeah, thank you.
Uh-huh. So I'm going to steal this command, and then we're going to go back into our Proxmox setup. And so we want to get a shell for this host 32. And so we just click on shell out here in the middle. And then it's best not to do things in here because if a window closes or whatever, the shell isn't persistent. So if we click the drop down and go to Xterm, it gives us a nice little GUI way to get to that shell. So with that up there, we need to go to that directory that we just dumped those files in. So for me, that's going to be in my mount, PVE, NetLab 1. And then we have our, oops, I'm on the wrong host. That's why. Give me a second. I copied these over to the wrong host. They should have been on 32 and not 31. Okay, so let me try that again here. Sorry about that. So mount, PVE, NetLab 1, create our folder. Actually, I called it import if I remember right. Sorry about that. And we'll move those across too. Now, if you were running just straight VirtualBox, at this point, you could just double click that OVF file and it would bring it into VirtualBox for you. And that's great because then you can kind of host that locally for doing dev testing or playing and that kind of thing. So if you want to do that while you're following along here, that's perfectly fine. I just want to get in an environment that I can export to you guys later kind of thing. So that's imported in. And then let's see if my shell works like I would expect it to now. There we go. And we got our OVF import file, our folder, and our two files that we put in there. Now, obviously, these names are a little wonky. We probably should have cleaned them up a little bit, but it'll still work for what we're trying to do. And so again, if we steal that command I had out there on the website, I'll talk a little bit about what that does. And so what this will do is import that OVF file that we had. We just need to point out to that OVF file. That's this one here. We need to tell it what the data store we want to put it on is. For most of you with a basic Proxmox install, this is going to be called local-lvm, all lowercase. In my case, I needed to go to this disk, which is NetLab 1, and just to format it as a QCOW2, and that's kind of a de facto standard that we use. So I'm going to go ahead and enter, and it's going to take those files and import it into the system, and we can see it show up over here on the left-hand side. Great. And so we're done with this shell. We can close it. And over here, we have our Bizarre Adventure Joestar virtual machine. So it's fairly simple to get it down from VoltHub and then deploy it on Proxmox. Again, if you had VirtualBox installed on your system, you could simply double click that OVF file and it would go ahead and launch it in there. If you were playing with Workstation and such, it would obviously work the same way. So like Michael pointed out, if you had the free version there, you could simply come into that folder and I could double click this OVF and I'm just going to say I want to use that in say Workstation. Pull it up here. And it didn't like that virtual disk, of course. So it did say that it works better in VirtualBox. So just to confirm that, I'm going to go ahead and install VirtualBox.
I'm loading mine now.
So I'll go ahead and do that just so we can kind of run those in parallel here. All right, we'll go to the host and win. All right, so VirtualBox is getting downloaded and installed. And I didn't do anything fancy. I just went out to VirtualBox and we'll see if it works on this system. Because I have Workstation and I have WSL and some other stuff, there's a chance that it could cause some conflicts and issues. So we'll see, make sure we have no issues there. How many of you have student organizations or clubs for cybersecurity? Okay, just a handful of you. Great. All right. So hopefully these kind of tools would be great for you to help them, train and do things outside the classroom that you don't have time in there, that kind of thing. Yeah, the gaming side of the house, yep. So back when I was a student, I was a part of a student organization that really scheduled trips and things to different businesses, and we got jobs for lined up for students, that kind of stuff. And then eventually that kind of morphed into some of the esports side of the things. And so that broke off in a branch, and then we had a cybersecurity focused one that really did to capture the flags and that kind of stuff. And so now that I came back as an instructor, I sponsor them mostly for the cybersecurity side. The esports is off on another side, but it's pretty big for the students to be able to do some of those challenges, especially if you get into the introductory ones and that kind of stuff. For say Cyber Skyline is an easy one for most students to get into. And kind of do some simple training. If they're younger, you can do your Cyber Patriot stuff. That's usually high school level. And we do have our guys go and help train high school students for Cyber Patriot too. All right. Yeah, go ahead. Sorry, what'd you have, Terry?
I was gonna say, comes up to this login screen. Is there a default? Yeah, I guess I can check. I can check that out. I can look it up. Hold on.
Yeah, see if there's one on the website, because I can't tell you off the top of my head if there is one. Let's see. That brought up VMware. That's not the one we want. We want a VirtualBox. Let's try that again.
Let's go back there.
There we go. All right. So for those of you that were playing along with VirtualBox, we should be able to import and go out to that file that we downloaded. So let's see. It would be this one here. Joestar. Just kind of do a simple click all the way through. So as far as your network that you would want this on while you're playing with it, make sure you go ahead and do the NAT so that you're not out there on the public internet right away. The other benefit of this is it's going to hand out DHCP for you. You're going to find out when we do this on Proxmox, there's nothing to hand out DHCP, right? Because it's inside of a sandbox environment. So we're going to end up having to create a little VM that does nothing but DHCP for us. And that's easy enough. That's, again, part of what it takes to build a CTFL. So this all looks good. We could do it as a VDI or however we want to do it. That's fine. And hit finish. And then to answer your question there, Terry, I don't see that they provided the username and password for us. So I think that's part of the challenge of what we would have to do to find a way in. Sometimes they'll give you like basic logins and that kind of stuff. But again, the idea is that this is a vulnerable virtual machine. You have to try to attack it and figure things out. So
Okay.
in most cases, like this is a server running, right? So that means we need to have some kind of desktop for us to hack from, and Kali's kind of the default standard for that. So here in a minute, we're going to go ahead and deploy Kali and hook it up on the same network as this one, and then start being able to do some scans and tests and things like that. We'll walk through essentially a full-blown pen test, as far as I'm concerned, in order to figure out what's available on this VM. So if you didn't know it, you get to do a capture the flag type style today. Okay, so yes, this would work over here in VirtualBox. Again, we have it on a network that has some DHCP and stuff. You could go ahead and fire this up, and what you'll see is just a Windows terminal prompt, or Windows terminal prompt, just a Linux prompt here for it to be able to access. It's an older Ubuntu 17, like Terry mentioned there. But it works for the purpose of what you're trying to do, right? It's just a VM. So let's see here. I need to fix some settings on mine, so give me just a second here. It's going to go out. Let's call it that interface. Not sure which one's which. Okay. And so all I'm doing is just kind of watching it, seeing if there's anything that breaks that sometimes doesn't work in these environments. In this case, at least when I fired this up earlier, it didn't seem to have any issues. So right now it's going to go try to get an IP address on the network. This will tell me whether or not I picked the right IP address network. I'm judging by the way it's sitting there. That was not the right adapter. Neither was that one. I got too much running on this machine. Oh, let's see here. We were looking to do that. Reboot it here and see if it pulls a IP for the portion of VirtualBox here. And then we'll bounce back to Proxmox because that's ultimately where we're going to want to live. So if you watch this close enough, we can see that looks like he's got a container running inside. And I say he because I assume this was written by Joe, if I recall. Could be wrong. I thought that's who it was. Yeah, Joe Haas Antonino there. Anyway, it would boot up, get an IP address, and then you'll get a prompt, but we don't have logins because that's the purpose. We're trying to figure out what's all going on in there. So I'm going to shut this down for the purposes of what we're doing here. And over here on the Proxmox side, we do have our VM now. There's a couple things that we would want to do down the road to make this more useful in the Proxmox environment. We would want to make sure we get the QEMU guest agent installed. So we would have to do some tweaks to the underlying VM to make this work. And that gives us back the ability to do a lot of different things in Proxmox automation-wise. But for now, this will work great. Hardware seems to be aligned. It's got a gig of RAM. Looks like just one core, one socket. Because this is a server-based image, that's okay. If you were using a GUI or something, we tend to recommend that you use at least 2 cores. And there's some other tweaks that we would make along the way for a GUI-based VM. So we've got this one up and running. I do like to take snapshots right off the bat. And the reason for that is if something goes wrong or I break something, I have something to revert back to. I don't have to start that process all over again. And I try to do that before I do the first boot in that side of it. You could do the same thing in VirtualBox. I believe you could come in here and do a snapshot as well. And you could take that first snapshot before you boot it so that if you broke something, you could have something to revert back to. All right. So in this Proxmox environment, the way I have the hardware set up currently is it's going to end up firing up, see if it comes up here just to make sure. Should have a network adapter out there, but it doesn't look like it added one, so I want to make sure. Yeah, so it booted right up into it. And let's see if it just so happens to have tools. It would pop up here and tell us that the guest agent was installed. I'm guessing it doesn't. Yep, doesn't look like it. Okay, so we're going to temporarily go ahead and shut this down. And in our case, we're going to have to add at least a NIC card in here because it looks like it didn't add it when it did the OVF import. So we'll add a network device, and then we'll need to put this out to whatever network. in our case, or at least where I have my dev system, I'm going to go ahead and put it in my safety net. And safety net is just a adapter that has no real connection out there. So it's like it's in its own little sandbox environment. In a physical world, you could picture this being plugged into a switch with nothing else plugged into the switch. That's kind of our goal. It's best if you create one of those before you start. So we can even create one for our little environment here. If we go to host 32 into our network, we could create a Linux bridge. And this Linux bridge, we're going to give a name of, say, CTF. And we'll make sure not to do anything else on this inside here. We don't want to attach it to a real port. And we're just going to call this our CTF network for now. Perfect. There are some naming requirements and structure and stuff that you can do with these Linux bridges. You can't just use anything. But creating our own little CTF one here is a good idea. So then we go to our Joestar VM. We'll go ahead and add our network card. Make sure it's on the CTF network. And then we'll go ahead and use the VirtIO drivers. Hopefully those are installed and should be able to continue up from there. If not, we'll go back and just use the standard Intel driver. But performance is always better with the VirtIO on Proxmox. All right. So because we got that added, I'm going to go ahead and remove that snapshot I had before. And then I'll take a new snapshot because now we made a hardware change. And so let's go ahead and turn it back on just to make sure everything boots like we would expect. Let's see here. Got a failed start. Didn't like that. So let's go back here. Oh, we can turn that firewall off. I didn't mean for that to be on. Let's try that. And of course, we got to take a new snapshot. Otherwise, when I roll back later, I'll forget that I made that change. Okay. Let's try to start that up again here. And we still failed to start. So what did it not like? Okay, let's try that again. Options, hardware, network. Let's go ahead and just set this back to that E1000. Make sure we're okay there. Oh, I know why. All right, so when you do this network change that I did here, you have to click Apply Configuration. Okay, so now CTF is an actual one. You can tell that by looking at the active column. Make sure this says yes. And so that will make sure that everything's good to go. So now we can go back to our Joestar. Let's go back here, make sure we go to the VirtIO, CTF, no firewall. That looks good. And then we'll just take a new snapshot to make sure all our changes are set up correctly. Okay. And if all goes well, we should get the VM booting, which looks great. And during this boot process, we should see it get an IP address, or at least get past the part where it's looking for one. Looks like it pulled one, and we should be good to go. We don't know what that IP is yet. We'll have to do some research and figure out what that is, but that should get us back on that side. So from there, I'm going to go ahead and close that and shut that down. And like I said, we're going to need something to attack that with. And this is common when you're doing capture the flags. Most capture the flags that I've been around, they give you some client VM on the network. You found a way onto the network, right? And it simulates them walking up with a laptop and plugging in and going from there. You can use Kali Linux. You could use Parrot. You could use anything you want. We're going to use Kali just for simplicity, and most cybersecurity instructions all kind of come from Kali. I should ask out there, how many of you guys use Kali versus Parrot or some other platform for teaching in the classroom? Most of you using Kali? Okay. All right. So for the Kali, again, out here on that same page, There's Kali Linux here, and they provide a nice little tutorial on how to get Kali up and running on Proxmox. So you're welcome to follow through with me here on the Proxmox side. If you choose to do this on VirtualBox, the good news is, again, it's all built out for you. So if you come out here and go to their virtual machines and VirtualBox, you can go ahead and just download that directly, and then you can load that up in VirtualBox side by side with your Joestar VM that we downloaded before. So again, it makes it a little simpler bringing it in if you're just doing testing. You could go into your VirtualBox one, which I have on the other side here. Yes, I already downloaded that. I just need to extract it. Cancel. Go. And so now, folder here. Let that extract. Okay. And then with that folder out there, we can go in there and you could go ahead and launch your image, which is this definition here. And that should go ahead and pull it right into your VirtualBox. And then the only thing you'd want to do on that VirtualBox, if you're following along there, is go down to your network and make sure that you have your adapter set to NAT, which is the same one that we have this vulnerable machine set to as well, right? So we can double check that. Network and NAT. That way it's all set up on the same network and pulling IPs from that network. Because it's set up for NAT and doing that, then the VirtualBox is going to act like a DHCP server and hand out IPs for you. We don't have that luxury on the Proxmox side. We actually need to have something hand out IPs. Ultimately, if I was building this one, I would set up my VM with static IPs, and then you wouldn't have to worry about that. But because the images coming down from VulnHub typically have DHCP set up because they're looking for people to download them and put them in VirtualBox or Workstation and run them locally, not host them for students to be able to access, which is what we're ultimately after in a classroom. Otherwise, you're going to require students have, fairly beefy machines. And in this case, they could do this as simple as a Chromebook. All they need is access to the VNC session.
Jason, do you have a VPN to the Proxmox server from outside the campus? Is that how you do it?
So my stuff is all set up in the data center, and then I have a VPN that dumps me on that management network over there. That's how I would recommend deploying it. And then it all sits behind a firewall that allows it, whatever resources you have. But if you have a public IP for that, obviously I would put some kind of firewall in front of that just to help filter traffic.
Thank you.
And then, of course, if you're in a lab, right, and it's not routing anywhere, then you're fine. You could just, like for example, what Ravi's talking about, where he just walks in and it's on its network. The only way you get access to it would be through like his Wi-Fi access point kind of setup, which.
Yep, it's a sandbox with Wi-Fi. That's the uniqueness about it. It's not wired, so it's completely mobile.
Perfect. Yep.
Well, I have a couple of.
Go ahead.
I have students that VPN out of Dallas into the WCJC network unopposed, so to speak, into my lab in here. And I got one of them coming in here today, and I'm going to pick his brain on how he does that, because I've never seen it documented on how they're doing it.
Yeah, I mean, every campus and network will have their own little setup. In my case right now, that particular setup is I get a public IP from campus, and then I have that running into an OpenSense firewall. That allows me to do the stuff that I need to do from it, and including VPN access straight to that firewall, and that'll dump me on my management network and such. So ultimately, that's what you see going on here. So there's just a open VPN connection going to a OpenSense box over there.
I feel like if I talk about that here,
Yeah.
I'm gonna get shot. So it's better to do it under the covers, you
Um,
know.
yes, sir. I do 100% know what you're talking about. So,
Okay, all right,
um,
thanks.
I mean, no, we're on recording. I have no clue what you're talking about. So,
Yeah, me either.
I didn't hear anything.
I ask for forgiveness all the time. All right. So again, that's how you would get that set up in VirtualBox. For the Proxmox side of the house, again, they had instructions on the best way to go about that. And so we're going to follow with those slightly. I'm going to deviate a little bit because it's a lot of extra steps that don't need to be there. So what they want you to do is obviously go grab the image for QEMU. So if we come out here for the pre-built images, virtual machines, and the QEMU image, and we would download that image to wherever on your local machine. I've already done that, so I'm going to bring that back up here. All right, and so part of those downloads, what I have is this little QEMU, and I've extracted it. And it comes in when you get it as a QEMU there dot QCOW2 image. And of course, it's not going to let me do that now because I already renamed it when I was following their instructions, and it's a little silly. So we're going to stick with their instructions just to kind of show you what they're doing, and it's fine. It's not a big deal. The reason they do what they do in their instructions, I can kind of explain that. They have you convert it to a quote unquote ISO image just by renaming it to ISO. The reason they do this is because, again, there's no import feature in the UI of Proxmox. So if they make it an ISO, then they could upload that really easy to Proxmox. So if you come in here and you click on your data store and ISO images, you can say upload, and it will let you upload that ISO image. All right, so we're going to do that. And then the key is once they get it up there, they just rename it back to a QCOW and use it to deploy. So they're just trying to use the UI as a method. I tend to use just FileZilla or something like that, like we did with the Joestar one, because there's more files that are easier to upload. So you'll notice this ISO is a little bit larger, being Kali Linux, right, than our Joestar one. So this will take a little bit to get it up there in the system. And while that's happening, let me double check because I bet we're real close to. And we are. So we're at the first break coming up there. So I'll let that upload while we start in on the first break, or I'll at least pause the recording here. And so where we left off is we have our Bazaar. I'm going to full screen this up so we can see it a little easier. We have our Bazaar Adventure one that we got from VulnHub. We have a Kali Linux box over here so that we have something to kind of go through attacking. We wanted to double check and confirm the settings in these to make sure that the network is under our NAT, and that way it will pull an IP address and essentially have it on a sandbox network. It would still have internet access because of the way we're using the NAT, but that's okay for just firing this up for testing purposes. So. Okay, that looks good. So we'll go ahead and just start up both these images. I'll be honest, it looks like VirtualBox has come quite a bit further since I used it long ago. There we go. VMs are starting up. Come on. hopefully we can get these a little bigger here once we get going. Okay, let me see if I can do some resizing down here. It's been a while. There we go.
You can also pull your ISOs or images off that fog server onto this Proxmox, right?
You could, yeah. Yeah, I mean, so like when I did them as my fog site, it's really just loading it up for the system itself so that it has an like we already have it tailored for our lab, or if a student goes out and uses it, it just blows back in the Windows and or Linux or whatever we want them to run. So
I guess it'd just be better to have it on the Proxmox in a file folder.
yeah. Let's see here. All right, I'm trying to get these where we can actually see what's on the screen. Hopefully that's a little easier there.
We should have had like a snap, like Windows, just, and just
Yeah, I mean, I guess I could kind of do that. We'll see if it works. Meh. Maybe not.
Well, sorry.
Nope, nope. Worth a shot. Worth a shot. So I'm noticing over here that this one didn't get an IP. We'll confirm that with Callie over here just to make sure I got my network set up correctly. So default login for Callie. And then let's go out here to quick shell, do an IP add. It looks like we did get an IP, at least a 10.2.15. So I know that one should be okay.
Yeah, for the net.
Bizarre, however, doesn't look like it pulled one, even though it's set up. Oh, well, that's always a good plus there, right? The old layer 1. In this case, layer 0. All right, so there it pulled it. Okay, so obviously in your settings there, if you're looking for what I screwed up, I forgot to make sure that cable connected was there, right? Even though it's virtual, we got to remember the physical layer. Yeah, that's what I was missing. Okay, good news. We got 2 VMs up and going. So we have an IP address over here. Great. This one has one. We just don't know what it is yet. So what we want to do, and we really don't need to use this as a UI anymore because we don't know what this is or what's on it. We just need to go figure that out. So that starts our pen test, and I'm gonna, let's see here, just cancel that. We'll let it run in the background, but I want to make our Kali a little easier to play with. Let's see if we can just a little bit of resolution so that it doesn't hurt everybody. Let's do settings. Nope, not that one. There we go. All right, can everybody see this okay in the Zoom?
Yep.
Be able to read text and everything? All right. So there's a couple ways we can get started, right? And if you know anything about Kali, it helps us through the process. We got our numbers over here on the left. We need to start with some simple reconnaissance, and let's figure out what's out there. So we could do some Nmap. I'm going to throw up ZenMap just to keep a little bit of a GUI for everybody. We can see what's out there. So we know just by doing a little IP add over here that we are on a 10.0.2.15 network. It looks to be a /24. Just based off the broadcast, obviously we have that there. And then what we want to do is just target that entire network and see what comes back. So I'm going to click over here. 10.0.2.15. And instead of 15, we're going to do a 0/24. Again, we're just going to scan the whole network, see what we can get back. We're going to start with just a simple ping scan and hit scan. And so, based off that, we were able to find something at 2.2. We found something at 2.3 and something at 215. Well, we know 215 is us. So there's at least two other services out there on .2 and .3. All right, it's a good start. So let's do a little more of an open scan. We're going to go ahead and just hit an intense, and we're going to do this on 2. And let's see if we can figure out what bites. So 2.2. And it wouldn't hurt for us to figure out what the operating system is on that one too. So I'm going to throw in a -O, get us a little more information. Let's see what it comes back with. Oops, I didn't change that. So let's cancel that. We're going to take off our /24. We just want the single host that we're going to be running the scan against. So make things a little easier for us to pull. All right, let's scan. And so another reason I tend to, everybody trains people differently, but I have them use this in ZenMap, particularly because you're going to collect so much information in here, and it gives a nice detailed of overall scans of things that you've done and helps you end up building this topology. At the end of the day, this is the helpful part, is we can figure out about these hosts, and then we can start diving and getting more information about what those individual hosts have, along with what protocols are open, et cetera. So we were able to gather some decent information on .2. It looks like we have 80 open. Let's see here. We've got some other unknown ports that I don't recognize off the top. Looks like there's actually quite a bit of ports open on this thing.
Yeah.
So this particular scan that I grabbed, yes, it's going to go through all TCP ports, 65,000 on up. We could just run with a simple one, but it's kind of nice to figure out what's all there from the beginning. It does take a little bit to run that scan. I think at this point, we could probably shut her down, and we know that we're at least somewhat close here. What I want to start with is 80, right? That's a pretty easy one to start. We can go to 23. And on the 23, let's do just a simple intent scan there. That should get us at least the known ports that we're after. And we didn't get any information back on that one. So I'm guessing that's probably our little DHCP box or something like that on the network. Why it's .3, I'm not sure. But looks like it's an AT&T voice gateway. Well, I think we can assume that that's not the case. And that because it just has 53, the OS detection tells us it's more than likely a QEMU user network gateway or an Oracle VirtualBox NAT bridge. All right, so this is our default gateway for our network, right? And we probably could have got that information over here from the simple commands on this box to figure out what we got as a default gateway. Or route, right? So route tells us our gateway is 2.2 actually. It's interesting. We should have had that off 2.3. Well, we'll see what's all coming up there. So let's throw up Firefox here. And let's just do a quick browse. That's my host machine. Obviously, somehow it's pulling up on this side. So what's happening is my project that I ran, it's listening on all interfaces, and that's why we're seeing that inside. I guess that's interesting. So that was my host machine that had all these ports open on there. So we do want to kind of focus in on 2.3. So let's do a little more scanning on 2.3. Scan up here. So hoping we would find some pretty basic ports or something running on this guy. Now, does anybody know what kind of the problem is with doing a ZenMap scan? Or an Nmap scan?
Well, if we don't run in stealthy mode, I guess it gets detected, right?
Yep, we could do a little bit of that where we're getting detected. Um,
Let's just say logging.
there's logging that we could be pulling up on there. The real kicker is just because the port doesn't say it's open doesn't mean it's not there, right? Um, and that's where a lot of my students will fall trap. Well, it doesn't show it's open. There must be nothing there. No, it just may be blocking traffic on that port. Doesn't mean that it's not there. Or it's like you said, it's detecting this kind of stuff and deciding, all right, maybe we should not allow that traffic in. But it looks to me like all I'm getting back out of this thing is a simple 53. Just to make sure we can go out there and do a simple browse to this one. And it doesn't look like there's any website there. Let's check the standard HTTP. Okay. Interestingly, as I'm doing that, it's sending that back over to HTTPS, which almost tells me there's some kind of redirect, right? Yeah, there could be a sinkhole or something that's just pulling this kind of stuff in. It's interesting. Just to make sure that there's no website on 53, doesn't look like there is. Typically it'd be DNS, but that means that there could be a website running on there, right? Just because it's port 53 doesn't mean that it's actual DNS traffic going across there. So, what do you think from this side? What should be our next attack to that virtual machine? Anybody got any thoughts? Yeah, we could scan for all TCP UDP. Let's see what happens there. At least on the TCP side. Yeah, Euritza. So while this one's running, I'll show you back up here. On the website that we've been working with, I have to go back and grab my own link here. And that is the summer working connections one. That's back up and going, and we have it's running on port 80. If we go out here to VulnHub, we are looking at the Bizarre Adventure Joestar link that's here at the top. And again, you could download that VM, and then we just brought that into VirtualBox for the time being. And then we went out to Kali Linux, and instead of actually grabbing the one for Proxmox, we just grabbed the one for VirtualBox there. I'll put a better link in for that here in just a second. So let's do copy link address. Great. Let's see here. There. Okay, and there's a direct link for the Kali on VirtualBox there now on the website too. Great. Okay. Yep, no worries. So let's get back up our Bazaar here. That looks like it's going in there. Let's see, how's our scan doing? So it looks like we didn't pick up any more ports on the TCP side. This point, we're just going to need to kind of find a way into this and find out whether or not there's any kind of credentials. We know on the website there wasn't any there. Maybe we could just use worst case, little bit of brute force in order to find out whether we could use one of the password lists to get us an SSH connection in there. We could obviously just try basic stuff and make sure there's nothing goofy there. So SSH root at 10.0.23. Whoops. Let's see here.
This is looking more like my final, where they find the open ports and they see SSH and they have to use it to try to access me. And
Yeah, you got it. And it looks like whatever reason SSH isn't open either, right? So,
yeah,
all right. We're gonna switch gears and just go here. Let's see what we can find. Root and password.
I did the UDP scan as well, but I didn't see anything. So I was definitely looking for what you're doing next.
Yeah, usually on these they have at least SSH or something that you can get rolling with. I'm surprised it's just DNS coming out of there. And again, this may be a bad VirtualBox, right? So my goal was just to see, because this one said it was SCADA, what might be coming out of there. I'm beginning to understand that this may not just be SCADA that's in there. And if we don't find anything here, which I'm not seeing anything on there,
It's still fun. This reminds me of the challenges we get. Like, okay, what is this thing?
you got it. You got it. And there's better ones out here. That one was honestly a pretty old one that had been out there. If we look at the timeline here. Well, here's a good example of the Morpheus one. Does this give us any kind of directions? No, not really. So what do we got here? Theme throwback from Matrix. You play Trinity and try to investigate a computer. All right. Well, once again, be nice if we know it comes up there. So the benefit of most of these, and that one has a Morpheus login. They used to have good information to go along with these. These seem to be much more obfuscated as to what they are.
Yeah, that's not like a cyber skyline. It's obfuscated. Go find it. Like, oh, great.
There you go. Here's a CTF box that happens to have a Discord server with it. So,
Oh, nice. Which one is that? Hold on. What are you grabbing?
this one was Empire Lupin 1. Let's try to see if we could get something that was still more OT focused. But at the end of the day, like I said, once you figure out the concepts of the CTF, then, adding OT stuff to it isn't all that terribly hard. Well, relatively speaking, right? Unless I'm missing something here. They used to have really good descriptions and stuff, and it seems like people are getting more and more there you go. So like this one has a walkthrough. That's a good start. I was gonna say, but some of these used to have quite a bit. Let's see if they happen to still have that. Okay, great. This is a good one for at least as a walkthrough, so we can figure out the answers, but not actually do them right off the bat. And kind of test our skills. So forgive me on the bizarre one. When I was testing that this morning, I could have swore I had SSH open, but I see now I was probably pointing to my own box. So that's my own fault there. So let's close that down. We can go ahead and leave Kali up and running for the purpose of what we're doing here. But we will want to.
Oh, I ran Mmap and I ran ports on 502 and 102 and some other scattered known ports, and I found a bunch of more results came up.
On the UDP side?
On the, oh God, what is UDP? TCP side, actually. I see 102 is open, port 502 is open.
Well, that's what I would have expected to see out of there. I wonder why I wasn't seeing that. Right, well.
Yeah, I added Mmap. All I did was the Mmap SS. I did -P, and then I added some of the ports that we've been talking about, like that 502
Ah, okay, okay.
specifically, and then I did script banner. I did that script banner that I know that gives information because we did that in Cyber Skyline.
Yep.
10023, and it gave me a bunch of open. I mean, I could be wrong. Maybe you could test it real quick, see if maybe I'm
No,
on.
no, I like it. Like I said, I was finding a whole lot of stuff earlier, so I'm just kind of dumbfounded as to why no, it wasn't. So let me get this one booted back up, make sure it's in there, and then we'll.
Need to boot you back up because I don't see SSH still, so that sucks.
Well, no, but if it's acting like a SCADA system, which is what it's supposed to be,
Looks like a SCADA system. I see a bunch of those ports. I've just pulled up some SCADA ports that we talked about yesterday, and also some new ones I didn't know about.
yeah, because if at least we get to Modbus, right? The idea here is okay, well, let's use some of the stuff we learned in those first 2 days to come over here and see if we can't pull information out of the Modbus side. So.
Yeah, I could, and forgive me, I could have just shared my screen and have you go all the way through that, but
Oh no, that's all good. So on this one, you want to share the command that you used for?
I did Nmap and I threw in. I started with the SS, even though we don't really need that. I did the -P
Okay.
reports, and I specifically listed 502. And then I threw in. I asked. I Googled some things, searched up some things. I saw 102 was the Siemens things from yesterday. I think 102 Siemens S7.
Yeah.
And I threw in those two ports, and I just started with that. And then I went then I did --script equals banner. We do that a lot, and then I did 10023.
Okay.
I don't know if they'll do the script through Zipmap. I guess it would.
So yeah, it looks like 502 is there. It's just filtered, right? So that
Yeah,
makes a little more. So
yeah,
yeah, focusing on the just straight OT scans, which again makes more sense. I'm more in my head, I was attacking more of the cyber side of things, so this makes more sense.
Oh, I found some other 20,000 range. I did a 20,000 range scan. I found a DMP. I found Ethernet IP-2. I found contact. I found a bunch of little. Okay, what's it?
Great.
Why is 20,000 so? Is that a popular SCADA stuff?
No, I'm not sure on a 20,000. That one hasn't ring any bell the stuff I played with, that's for sure.
Yeah, DMP3 is what it's saying. Is usually
Oh yeah,
what.
DMP3 was another protocol we talked about. Yep.
Yeah, yeah. I googled DMP3 because we talked about it. And then it said add 20,000 to 20,005, and I was like, all right, I'll add it. You gave a bunch of. I just use Nmap as Nmap.
Yeah, so let's go.
I'm not sure how we can use to gain access to it, but
Yeah. So we talked about our ICS protocols, and this one, if you guys remember, we set up the VM and got it all running, and then we were able to use MBT Git, right? I'm fairly certain MBT Git was not part of a basic Kali, but let's find out. Pretty sure I had to go pull that one down.
oh yeah, MBT get. I remember you talk. Yeah,
Yeah, no. So that one won't show up there because that was a package you had to go get. And that allowed us just to interact with some of those pieces in there. But if you remember, the one that we really started to use um, was our Metasploit, right? So we did the one where we were scanning these systems like with Nmap. And then from there, we ended up using specific ICS scripts within Nmap to do that. So let's go down and use some of those same skills that we learned before. So we did a basic Nmap. We had a PN, and then we started using these extra scripts on top. So in our case, it would be something like Modbus Discover would be one that would help us get some info, things like that. The script that we used in the test here was the enip info.
yeah. I remember the script. I couldn't remember what it was.
And you said enip was up and going, right? Based off what you saw?
I think I saw it up. Yes, and that's how I was trying to remember that script. It was the script was enip info. That's okay. That's the one I could remember.
Yeah, so let's do a sudo nmap -- script. And we're going to use enip info -su -p, and that ran on 44818, right?
See, what was it? It was 44818.
And we can at least see it's there. It's filtering it out, but we can at least see it's there. So part of this is it's doing a little bit of filtering on these ports. They're not just wide open to the world kind of thing, right? So this is taking us all the way up to lab 10 that you guys completed, in which case we tried to do this man in the middle attack, right? And of course that won't do us much good with using Modbuster, even though that would be great if we had that script because it was all custom written. But we could take a look at the Metasploit under the hood that we used.
Yeah, I remember this. Yep.
Well, piggybacking on the Terry's
Yeah.
scans, I looked for that Control Things platform running on VirtualBox. Have you done that, Jason? Or you?
Which one was that?
I put it in chat. Control Things platform. In other words, what Terry was talking about, scanning the SCADA ports
Uh-huh.
in ICS. It says Control Things platform will run in VirtualBox for testing security on ICS SCADA.
So somebody's built a VM that's out there for it looks like.
Apparently so. So we could bring that into VirtualBox
Yeah.
and scan a SCADA network.
There you go. It's meant for doing a cybersecurity assessment. Great. So somebody's already built one out there. This would be a good one to possibly get started with and then do some flags against it. That's a good find.
And that was due to Terry saying what he said about scanning for SCADA ports.
Thanks, man. Hey, good. Wait, hold on. What's that website? Control Things.
I'm gonna throw it out there on the
Oh, sweet.
the
Yeah.
main link so we don't lose it.
Yeah, my man here is always throwing out some good stuff, isn't he?
Yep. I've tried to throw as much as I can on the website if I can get them copied out. So let's see here. This will be throw this under CTF.
Who was that? Who was that? Was that JB? Who was that just now?
Yeah, it was JB.
JB, that's what I thought. Yeah.
Yeah, I'll go ahead and I've been sending you stuff, Jason. What I'm watching, but I'm also asking AI a bunch of questions. So, yeah,
Yeah.
multitasking away, and I'm sending it to you in emails.
I'm trying to think what we did before ChatGPT AI, like before this existed. What did we actually look
Google.
things up the old-fashioned way?
Lots and lots of Google.
Or Google?
Let's see here.
Wait, where's Debbie? Debbie, you're quiet out there. I know you. Where are you? I know you're with us. I'll get her to talk. Let's see how you do this part.
Okay, so what he was just talking about there, I threw out under the the website there. So there should be a control things that we can have access to. That one, that went straight to a Kali. I forgot to change the URL. Stand by.
I'm dying of curiosity if Metasploit will do something. I'm gonna open up Metasploit too just to test something.
Yeah, that's what I'm gonna end up firing up Metasploit against it, but in the background, might as well have this one coming down since it's kind of meant for us going against it. So let's see, I'm gonna pull that down from Google just because that's a little bit faster.
If you get that, let us know how we can get it quick too.
Yeah. Like I said, the URL I put out there on the website, and then we'll see if looks like it runs in VirtualBox, which means we could clearly convert this over to Proxmox 2. So this might be an already vulnerable. To me, this sounds like this is set up in a way that OWASP, right? Where it was this kind of damn vulnerable Linux or any of those, or damn vulnerable web server, if I remember right.
What does it stand for? I remember the initials acronym.
So that one's a good one for doing that kind of stuff. And it looks like, obviously we can run it here for Virt Manager is similar to Proxmox. So you would follow these same steps to do that side.
Ooh, you
Um,
search Modbus. When you search all these Modbus and SCADA stuff, you find a whole bunch of them out. Oh,
yeah, it looks like they're doing some training out here. Oh, this is part of the sand stuff. Nice. Okay, so that course that we found the other day, the 410, this VM was built for training on that course. Good catch. See, it comes back full circle. Cool. Well, what was I doing here? So let me get back to where we were at. And so what we were looking for was a little bit of MSF console. Yeah, let's full screen that up a little bit. So we're going to try to use some of the Metasploit stuff that we learned in Lab 10 to see if maybe we can pull something off the Modbus side. Okay.
what was the
And
what
that
was the
mod,
port?
go ahead.
What was the port for 44? What was that port again? 44 something 18?
For ENIP was yeah, 44818.
Okay, there you go. I forgot. Yeah. Yeah. I suppose you
So
got
the
that.
module here would be auxiliary scanner SCADA Modbus. And it looks like it's good to go. And so obviously, again, to figure out all the variables we would want to test, we could do a show info. And by default, it's right now set to the read holding registers. And if we go to set, we can see what variables are currently set for us. And so we need to set our remote hosts. So that's going to be our hosts and then 10.0.2.3. Okay. We would want to set our port. So set our port.
What'd you search originally for that to get to where you're at? What'd you originally you just searched?
Oh, this is just following back in the labs that you guys did on
Oh
the
yeah,
lab 10.
that's right. Could you scroll up a little bit? I want to see what you originally. I see the set port stuff. I remember all that stuff. Where
Just launched the MSF console is where we
right?
got started.
And
And
then
then from there, use the Modbus client
oh,
module.
you went straight for the yeah. That's okay. That's what I was looking. That's what I was trying to find. I got
Yep.
all that up on my screen, but I was trying to figure out which I see a bunch of Mamba stuff.
Gotcha. Yep.
Uh,
Yeah, so that sets the host that we used, and then port would be 502. And then from there, we would have to know what data address we wanted to kind of read in, right? And we don't really have that information like we did in the labs. So let's just leave that part and see if we could do, yeah, for fun, let's just set data address and see what we get back. Worst thing we get is a read, right? So action, read, holding registers. And then let's do a run.
yeah, that's what I remember the address part.
Let's see here. Unreachable host on 10.0.2.3. 2.3 was our host, right?
2, 3. Yeah, that's what we're going after.
Yeah, so that was kind of what I was afraid of. For whatever reason, those ports are being filtered on that host. So even though they're there, they're blocking outside connections from certain IPs, is what I'm seeing.
Boo.
Yeah. Again, another reason it was showing up as filtered on there. So, all right, well. It's a good fun exercise. And then so that does lead us into something like this one here, which is great because this one's very much tailored for the purpose of OT, right? Um, yeah. So I'm guessing they're not going to give away the training, right? So, and the reason I say that is, these are the paid for classes as you go through there. There's a self-paced on demand. Yeah. Anytime they're asking for billing information and want 10 grand for you to take the class. So there's that. Well, it looks like a good find on the VM side, JB. We just have to figure out what they did with labs against it, right? So,
Yeah, but maybe your generation of those labs can be inserted into this. In other words, modify this to your what Terry and you are doing with the Modbus and SCADA and that type of thing.
yeah, I think that's what they have there.
And I'll go out and look for some more for SCADA Modbus image scans.
Yeah, like I said, that's probably the best way to get started in this because it'll give you some ideas on what you want to build out for the VMs. Um, creating the VMs from scratch is always great if you have a plan as to what you're trying to accomplish there. So, hardest part is coming up with the
Well, my thought process was simulated equipment like Siemens, and I mean, I know of Siemens. I got a guy that lives down the street that works for Siemens, an engineer. But some of the other devices, in OT, like HVAC controllers and motor controllers and stuff like that.
yeah. So it looks like they have this one set up for workstation, but they should be able to pull in the VirtualBox one too. There we go. Double check its settings. Set up for net and the cable's connected. Well, let's just fire this VM up and let's see what happens. Otherwise, instead of using these, what I'll do is I'll just take you through standing up some basic, like an Ubuntu box or something like that, so that you could set it up for a CTF challenge. We'll do a basic thing like bury a flag in the home folder and then have them figure out a way to get in, that kind of stuff. So let's see here. It aborted on the MDK side. So what we would want to do, yeah, they want you to have the extension pack. Okay. Oh, and they need you to make some tweaking settings. So let's do that. See if it starts. Looks to me like it has an issue with the VMDK. Yep, there was a power on issue with that VM. Well, let's try this. So let's remove this one. See if I can bring it back in. Double check those settings it was talking about. And it looks like all that's done by default. Did want us to give it a little more memory, but that should be all right for now. Hey, there we go. So interestingly, it looks like they are running just a straight Kali Linux image. So it's not one that you actually attack, but it must have some challenges baked into the Kali Linux itself.
And Jason, maybe you talked about this one, but I put it out there anyway.
No?
ICS Testbed Framework. It's a GitHub. That link takes you right to it. And once again, I don't mean to detract.
No. So this one, I want to say I looked at this way back when I wrote those labs. It's interesting. So it will allow you to deploy 1 HMU and 4 RTU units. Okay. So this one, you end up downloading all these VMs and then using Vagrant to create the virtual machine itself. That's interesting. Let's see here. What's always nice with these is they tend to piggyback off other ones. And so like this one, we'll use a little container to create like an internet. That's an interesting one. Okay. Like I said, this is great because I go off and think in one way and other people think in other ways and find more good resources. So I'm good with that. Okay, so this is one they wrote a paper on as an experimental test bed. All right. Makes sense that they did this in this way on GitHub because they're not actually distributing a virtual machine. You have to build it. Curious to see. How that one comes up here. So they've got a little SCADA front end, it looks like. And then they have the ability to turn on RTUs. Hmm. So it looks like it's just doing some emulation and stuff there. I'd be curious to play a little deeper and see if we couldn't use that as a VM to act like some of the other stuff there. Collection of automated scripts to build and deploy a variable number of virtual machines. Okay, so this would allow us to build virtual machines pre-configured to either be RTU units or HMI or even the data historian. That's interesting. Particularly the fact that it all speaks Modbus. So when we were looking at building out virtual machines, right, we used OpenPLC to act as those. There may be a way through this that we could build little virtual machines that would do something similar. May take a look at this at lunch, and if that looks applicable, I'll definitely pull it in.
I'll keep looking.
So unfortunately, this control thing ones is great, except I don't think they gave us username and passwords. That's probably going to be buried in their materials. Nope, nope, there we go. Control and things. Well, that's a super secret password. Get me out anyway. So I apologize if you were looking for a step-by-step today, but honestly, what I was hoping was just this, that people would find pieces. Let's see if it's relevant, keep all the links in an organized fashion, and that way you guys have some stuff to fall back on.
This thing from the Idaho National Laboratory looks really good.
Yeah, that's the one that we partnered with them as NDG to build out. Yep,
It's got a lot of cool stuff.
it does. They got some pretty cool physical equipment that rides along with that.
We'll create an image and then basically set that up and just clone that to all the other systems. All right, so with the rest of that you have to compare into some, so that's page management. And then configuration management is what I just showed you here. So establishing consistency, secure configuration, so baselines for system, and that includes monitoring for configuration drift. So if you have configurations that are sort of getting layered with other cruft that they should be there, and then automated tools to enforce the baselines.
If you were talking to us, Robbie, it was a little bit on the quiet side. It was hard to hear on that side, so I apologize if I didn't hear everything you said there.
I was just saying that it's a little way towards this is a different mic. Sorry about that.
Oh, yeah, no, that's okay. I can hear it much better now.
Yes. So I was just saying this is almost like community bond building.
Yeah, I mean that's honestly that's what I was hoping you guys
On the
would be
digital
open
side of
for.
things, this is fantastic because we have many good wise minds that are coming in and experienced, and there are experts who are trying to get in there, and then there are creative minds that are trying to like pitch in there, and then there are people who are like following on with the tasks, and that's a good number of people who are joining in with different forces. So that's awesome. So yep.
Yep. I'm glad everybody sees it that way because that's exactly what I was hoping for. And it's always hard to get that out of people, right? So
This is a definite community. When they said Discord, that's what it is, right there.
yeah. So this is cool. They built in some of these tools. I've seen these ones before when I was doing those other labs, and we just didn't have a Kali box in there to poke some of these. But this one's cool. So Modbus PAL is a way that you can listen to the pieces and create your own. I remember playing a little bit with this one. I'm just looking through this VM because obviously we don't have the instructions, right? So I'm just seeing if I can recognize some of the tools that they were playing with. Things, all right. Things is not their password. Okay. They must have had something else on the keyring. There's things. Nope. I was seeing what other tools they had. So they have a modified version of Kali Linux is what it looks like. Where it has most of the stuff that you would normally be interested in. It's there. But they also tailored it a little bit to ICS side. I wish they would have had some more info in here. I get it. I mean, if you're charging $10,000 for the class, you might want to hold all your labs a little close. Interesting. Okay. So where would you guys like to go from here? You guys okay with this? And then you guys kind of find something and see where we want to test. I do like the idea of that last GitHub that you sent me there. But I'll admit that one's going to be a little harder to teach because it's not an actual virtual machine. It's a Vagrant. So if you guys are okay and just following along with me here, I actually happen to have a VM already configured with Vagrant and stuff that we could just test that GitHub against and see if it comes up with something. Let's see here. So let's see if we can clone out a Git repository, and we want one that you had there, the test bed.
Hey, good morning, everybody. Or almost, actually, it's afternoon. This is Jerry back from my PT. So sorry for being late. Like I say, I had that PT I had to get done. Thank you.
Not a problem. You snuck in. I can mark you off on the Excel sheet now. You're good to
Thank you, sir. A gentleman and a scholar.
Yeah, sure. And I'm not sure which one, but I can't take both. So
It's like my colleague, Professor Dr. Hushkins.
uh, no, let's try that again here. Okay. So all I did here was I'm in an environment that has Vagrant installed and set up and configured and all that. I could do that in Windows, but Vagrant's a little bit more complicated to kind of play with. It's not overly easy once you get going there, but it's nice because it looks like they've got a nice little playbook here to create different startups and stuff. So that's good. Let's see what else they had. They had some good instructions on that particular site. And this there again might be something useful where I can build this out and then build out virtual machines for you guys and then just be able to host them. So that would be handy. Okay, so they have a Vagrant file. So let's pull up the Vagrant file. All right, and so what this is doing currently is trying to build out files for VirtualBox. We could tweak that provider and set that up for Proxmox or something else in between, but at least makes sense there. We got their bundles. Okay, well, let's just see. All right. Okay, we have a bundle install. And this is well, it should have been there. That said to go. Let's try that. Yeah, I don't see a gem file either. Oh, for Vagrant itself. Okay, fine. Yeah, so they want us to build the basic image. Let's do that. That will be a Packer file. So Packer build. Because that one's going to be set up for VirtualBox. So it's nano. Getting in the weeds here. Let's see. Vagrant image. They're building everything up against VirtualBox. So I would have to tweak this to work in Proxmox or something else unless we just do Vagrant on the outside. So give me a second. We'll get that fired up. So again, all this stuff that I'm doing here on the screen, hopefully you'll bear with me. this is what you would normally have to do if you find this cool stuff on the net. They usually don't give you straight VMs that you can just drag and drop and plug into your classroom, right? That's what I'm looking to do, is just be able to host these a lot like what you see with VulnHub, but have them set up in a way that if you did have Proxmox server, all you have to do is connect to the distribution and you can pull these VMs in with a little bit of documentation on organization and getting them up. And then once you do that, you're good to go. So that's kind of my end goal, was to work with all of you, get some ideas. And I appreciate you guys submitting links and thoughts and ideas and participating so that we can get that out. Because if I get some of those VMs up, well, then I can convert them out to Docker format. If you guys need them in Docker, we can convert them out to whatever will work for everybody's scenario. So, and obviously this applies to OT, but this could apply to just CTFs in general. So. Let this continue to go. So the plan here will be, we'll play a little bit with this other one, see if we can't create some VMs that act as PLCs or some of these RTU nodes, that kind of stuff. Because if we get that to work, then we can use them inside of our pod, right? But we got to find all the pieces to put in our pod. And I use that terminology pod, if you guys aren't familiar with that. It's just a collection of virtual machines in a sandbox environment. So it's kind of some NetLab terminology, but that's where I'm coming from.
Sorry, I'm creating more work for you.
No, not at all. Like I said, this is the hard part in the OT space, is coming up with the virtual machine. So like what you guys saw me present in the critical infrastructure one from NetLab, that didn't happen overnight. I mean, that took me about a month of just getting up to speed on OT one, and then trying to figure out, okay, this is great. Now, how do I go about setting up a lab environment for this? And I tested all sorts of solutions before I landed on that OpenPLC side of the house. And then, of course, once I got OpenPLC up, well, then I had to have somebody, in my case, help me write the script for the ladder programming and such like that. It was long before AI was capable of assisting you in doing that kind of stuff. So, let's see, I was going to pull up the topology is what I wanted to pull up. So originally this started out as about 8 to 10 VMs, and I had to obviously squeeze this down because the more VMs, the more resources that everything's going to take. Again, that book that we talked about was a really good guideline of setting up an ICS type of environment. And that's why I like all these links and things, because you can get some ideas of setting it up. And then from there, I was able to implement with the tools I could find. So again, this PLC VM it's a full-blown desktop running OpenPLC. And the reason we did a full-blown desktop was so that you guys could play with the editor, actually write program language, the PLC languages, things like that. Otherwise, this could be a very lightweight VM that just hosts and run, it automatically launches what it did in the labs for 90% of the time, right? We could just build a real tiny VM to do that. And by tiny, I mean, this could be, 256, 512 meg of memory, less than 500 meg in terms of storage of a drive. We can make it really, really tiny. And therefore we can have multiple of them. So I could end up with 20 PLC VMs out here, but they're super lightweight. And so we can make it look a little more like a factory and traffic a bunch of information back to the SCADA system. That part's fairly easy, but as you guys saw when we built our HMI, right? It would take some time to build out this really big, robust HMI that had all these tanks and all this other stuff in there, so that we could go about a much, much deeper attack sequence on all this stuff. And of course, if we build in usernames and passwords, then they're going to have to go one step further. It's not going to be wide open like it is in this environment. They would have to do a little bit of pen testing on there to see what would happen. So I think when we come back from lunch, the goal will be to kind of see if we can get at least some of these resources we're all gathering here together, come up with a game plan of what it would be like to build out a pod. Let's design a topology. That's really the steps in the process I went through when I did all of this. And then from there, we can kind of figure out what kind of labs do we want, or what kind of challenges do we want inside of there, and just bite off a little bit at a time, and not try to go for the big gusto all at once. Otherwise, we don't walk out with anything, if that makes sense.
Do we want to ask AI? I'll ask AI based on the text to create a syllabus. What about that?
Yeah, you can do that once we get an idea of what we're gonna come up with. Yeah. Let's try to pull up while that's installing some of the old basically when I built this lab set, because I had some pretty good demonstrations of what that looked like. All right, getting the rest of this in here. So I got my Vagrant side set up, and then I'll get Packer up and rolling here. Okay, so with that, let's see this environment up here. Oops. Might have accidentally just shut down the website. Give me just a second to bring that back up. Yeah, I apologize for the silence here, just trying to get organized in what we can do and building out some of these little VMs. And if I get them to work, then I'll make it to where you guys can pull them right here off the website so we can keep playing with it. There we go. Here.
Where'd you get the Vagrant image? Who led you onto that? Is that you or is that JB?
It was JB. He found this ICS test bed. And so if you read through on how that test bed works, they don't actually distribute VMs. It'll build them with Packer and Vagrant. But it takes a little bit to get up those environments kind of thing. And since they have this one done with VirtualBox, which is pretty common, at the end here, what it does is it ends up attaching to this local VirtualBox instance. Is this like the equivalent of going to like file new and creating a new VM from scratch? But it's a little automated, so it'll start the VM from scratch, install whatever it needs, then run through a script of all the different installs or packages that it needs on it. And at the end, it spits out this image. And then from that image, you can then use that with Vagrant to modify and tweak and do all that kind of stuff. But you have to start with a very basic VM. It's all steps that you would do if you were building a lot of different capture the flags and stuff. You would like to set up a bunch of templates in Proxmox. So like, here's a basic Debian install with a username and password that we know. And then we call that a template or a Vagrant box. And then from there, you would use Vagrant to use tools like either Ansible or Puppet or Chef to automatically start a VM from there, then configure it the way you want. And in this case, have vulnerabilities, bunch of other stuff pre-built into the system, and then shut it down. And at that point, it's ready for somebody to use. That's kind of the basis behind SecGen. It used that same thought process, just in a different language. Otherwise, if you're building them yourself from scratch, you basically build, an Ubuntu server image. We install, XYZ, like an Nginx server. We put a fake web server up on it or a website. And then once we get our website up and going, we can bake some other stuff in there as well. And I can do that. At least I can show you real quick on, let's build a quick Nginx website, and I can show you some tools in Python where we can randomly generate this data super fast. Now we have things like AI, and AI actually uses those same packages under the hood using Faker. And then we can basically build a fake corporate website in no time. So if that's of interest here after lunch, we can definitely go down that path too, because it does help for building these environments. Let's try that again. Of course, they don't tell you to make sure that you have all the extra plugins installed. You get to figure that out on your own. Good news is I'll try to get this all set up where it's documented here. Where we at here? Okay, so it looks like there's some errors in that code. And to be honest, this was updated 7 years ago. So it's been a while since they built this. And that's part of the problem is these guys start these projects and it doesn't ever get updated, doesn't ever get used. Obviously, they wrote this for a paper 7 years ago, so things have changed in the files and the templates and the stuff they did. It's part of the issue I'm having myself. So let's see here. So checksum. Yep, let's get rid of that. Let's get rid of the checksum. And we have to have a checksum. So my guess is looks like they were using Ubuntu to do some of this stuff, and it was an older 18 image. Let's see if this ISO is still available here. Of course, it is not. And they were using server. All right. So again, we're coming up 2 minutes here at the lunchtime. So when we get back from lunch, we'll keep doing what we're doing in terms of building out some virtual machines and testing and seeing what we can find out there. But at minimum, I'll show you guys how to build a virtual machine that'll have kind of a fake website on it, that kind of stuff. And that'll get you started in building like this scenario of this corporate OT environment. And for the language that we're thinking of, obviously we can use those AI tools that we talked about yesterday. So we can kind of come up with a scenario. I know JB found one yesterday for that, and we can kind of go from there. Yeah, it's a pretty good syllabus to get you started there. Yep. But we'll come up with a good scenario, something small that we can actually pull off. And then once we get that scenario under wraps, we can build out the virtual machines to be associated with it. We can use that template that JB had to see if we can at least do one piece of that to get us going. And we can go from there. So I will see everybody back from lunch around 1 o'clock. Should have started the recording. Okay, so we're back from lunch. One thing that we talked about was just getting Docker up and running with a simple Ubuntu server image. And so you should be able to run that command to get that. And you'll see this little Ubuntu Noble command come up here. So that works great. Again, that's just a little container that we could then run a web server in. We could do some other stuff in there to pull those files in. We would want to write our little web server outside of that. Depends on how you like to work. So for example, if I'm running in PyCharm, I could connect to that container and build a web server up on it, or build it from scratch using it as a Docker template kind of thing. There's several different ways to do it. It just depends on how you want to build up your VMs or containers, either way. Okay, I need a PowerShell command. All went well there. What I wanted. Yeah, that'll work. Okay. So VBox Manage came up there. That should be good. All right, what do we got here? I was trying to pull it. So we don't want it to pull it anymore. Let's take this out. It was trying to suck it down instead of us providing it. Let's put a new image in there. It should be good. So that was 180401 on AMD, that guy there. So just do a patch update in place of them grabbing the ISO. Wrong checksum, so we got to grab the right checksum now. Give me just a second to grab that. manifest file with all the packages in it. See if I can grab a checksum for that. Might not have changed from when it was there, but it looks like it. Nope, same. All right, let's see what we get here. Oh, nope, we got a double URL. And I remember asking earlier, but has anybody ever played with Packer or Vagrant or any of the HashiCorp tools? I think somebody said they played with Terraform at one point. Was that you, Michael? Is that right? I could be dreaming.
Yep, that was me.
Okay. My memory hasn't failed me yet then. We're good. Docker terminal states pull complete. Download a new image for great. So that just pulled to local, and then you'll want that very last one there, Debbie. That one will start up an instance of that Docker or of that image, and that will allow you to log in, and then you could do like apt-get update, apt-get install, excuse me, and get familiar with that image. So like here, you click on this, and of course, you don't have a website to go to like you did with the other ones, right? So for this one, you're just going to click on it and then go to exec. And then inside exec, go ahead and type bash. That way you get a standard bash prompt. And then you could do things that you would normally have in Ubuntu server. So you'd have something like apt-get. We don't need get. You could just do update, apt update, and update all of our packages. That's a good place to start. And then you could do a apt upgrade. Yes, and it will go ahead and update any packages that need to be updated. And then you could do an apt dist upgrade just to make sure we're at the latest one. Looks like we're good to go. So now you've got that system updated. You could start installing packages for different use cases or whatnot. So say you wanted a very simple, not to get sidetracked from this Packer stuff, but it's going to take a little bit here. Let me pull up the link we had. So say we needed a little virtual machine that would handle the DHCP that we were having issues with before. So if we wanted a little VM that would handle that, we could come in here and type set our root password, because right now there is no root login. So we could just do something like chpassword or chpasswd. I'm sorry, just passwd. And we could go ahead and set a password for the root here. It depends on if you want that to be hard so that people aren't logging into it in your CTF, that it's something a little more secure. For the sake of this, I'm just going to put password in there. So there's a password. And then you would want to do your apt update and upgrade, which we got. And then we would want to install a very simple DHCP server. And so that would be something like apt install -y, which just says yes automatically for us. ISC DHCP server. Okay. And so that installs a DHCP server, really lightweight on this VM. And then from there, we would need to configure the interfaces file. So if we go into Etsy interfaces, for example, oh, just Etsy. There we go. Cat interfaces. Come on. Cat interfaces. Nope. What'd they do? Change it on me? Yeah, it's not going to be interfaces now. It's going to be, find it here in a second. Networks. That's your networks. There should be virtual network file. Actually, on this base image of this, it may or may not have it because you're using, it's not a VM, right? You're using a Docker container, so you wouldn't be assigning that. All right, I already stumped myself here, Debbie, so forgive me. I would have to go find my notes and remember how to do that one off the top of my head. Should have an IP though. Yeah, that's because literally nothing's installed on this image, which is the reason I say go out. Like if you're going to do a virtual machine, go grab the ISO. Yes, there's really tight knit images, but that isn't super handy if you're trying to going through there. So no, I'm not currently at a document or anything. What I am using as kind of a template on this side is this one that JB found the other day, which was this capture the flag exercises piece. And so I was kind of using this as a rough one, but this is actually meant for a container. So I was trying to adapt it on the fly for what we would do for a Docker container. But we could do something like that. So what? All right, so why not use our dear friend, which is the whole point of some of this workshop, uh, any of your LLM stuff that you set up. So you could have used your local one to ask, or we could do something like this on this side. And so this one is just going to give us a real quick test to make sure it works. And it looks like this is what I wanted to test. Uh, okay, so when this one set up one, it's just running the network to the host, which would be fine. That would get us the internet and stuff. It kind of does that by default. And privilege just allows us to have more access. That way we can actually bind to the Ethernet and host DHCP. Now, I don't want to do this on my machine because I'm actually on a public IP. That's how you guys are able to get to the website and stuff. And I definitely don't want to host DHCP back out on that network. That would be a bad deal. But it looks like basically what we did before, we would just edit the DHCP config and get that set up. And then because it's going to use that default interfaces file, which is what's here, that's all we would need to do inside of a container. So that's one way to do it. Obviously, you have to do this by hand to set that up. The other option is you create what's called a Docker file, and then you build your own image based off this Docker file. This is the way most people build Docker containers, right? So the idea is we're going to say from Ubuntu Noble, which is the base, we're going to run a bunch of commands to get it all set up for us at once, and then we simply build the image and run the image. So this is a little easier, and I can show you how to do that. You could just simply go to your, let's pull up Docker here real quick. Let me get out of this VM that we're in here. And we're back here to this terminal down below, and it should be at your name prompt or wherever your users folder is. And we could just do something like Notepad and say Docker file, just because we're here. And if that works correctly, which it should, pop up Notepad on your machine, something like this here. And it did a dockerfile.txt file. We'll fix that here in a little bit. And then I will dump in what you saw there. Basically copy this piece in. And I'll post that here in the chat, but I'll also throw it out here on the website real quick because that might be easier to copy and paste. So give me just a second. Let's see here. Apologize. This is where I'm getting pulled in many directions, but we'll get this fixed up. So this is an Ubuntu Docker image setup for DHCP. And then we will have shell. Create a Okay, so let me pull up the website here just so I can demo what we're seeing. There we go. And so on this one, you should see a Ubuntu Docker image. Yeah, you're fine, Terry. Docker image that says setup for DHCP. And then it'll give you some instructions to just create a Docker file wherever you like, kind of like what I showed you there. And then save it. And then you're going to make sure that you just copy this contents in and that it's only called Docker file. So here, because we opened it up in Notepad, it's automatically going to give it a .text entry. We'll just save this and then close. And we did that from here, right? And so if we do a dir, we should see out of many of my files, we have this one called Docker file. We could just mv Docker file to Docker file without the extension. MV is just move. It's like rename on the Linux side, but because we're in a PowerShell, we can do that. We ls, we can then see we have this nice little Docker file here. And then from there, we just need to run the commands in this same terminal to build that image from scratch, which is pretty easy to do. I can find my window again here. There we go. And throw this in here. Sorry, give me just a second here. I'm just updating that website so it's easy for you to copy and paste. Okay. So if you refresh this, you'll get this next little part here. You'll want to build that image, which is what you got here. Oops, I forgot to put that other one in a shell command. Second here. There you go. You can refresh that, make it a little easier. So we'll copy this command off there and put that. I'm just going to put this over here, right in this prompt. And that will build a brand new Docker container file with all of our setup. Let's see here. Why did it have a problem with that? Obviously, this never goes the way you want it to on the first time. We're going to give it a shot. Okay, canceled that side of it. It shouldn't. Error. Aha, it needs a cache key. All right, so this is how we cheat when stuff like this goes awry. We just copy that little section there, throw that right into our handy dandy AI to help us figure out exactly which file we messed up. Aha. So because we're using build files, it was trying to copy it off the main system, in which case we would want to build that out ourselves. And we just didn't have that created for that to copy across. So trying my best not to make this super complicated, but we're going to need two files. So here's what I'm going to do, Debbie. I would recommend that you create a file just called DHCP server or something like that in your home directory there. Let's make sure that worked. Yeah, normally I would use an editor for this kind of thing like PyCharm, Visual Studio. It makes this a whole lot easier to see what's going on. And then we're going to move that Docker file we had into that. So mv Docker file into. Great. And then we can go back into that file. Okay. And then what we need is just a file in there that we're going to call the DHCPD conf file. So once again, we can just do Notepad here. Well, this isn't the best way to do it, but it'll work. Yes. Okay. And so now I have Notepad launch this little DHCP file. Perfect. And so now that we have that, we can simply copy this instructions inside of here. Now we could either do it here through Notepad and such. This one does it where it just does it right on the Docker or on the PowerShell prompt. That would have been handy too. But we'll just copy and paste what we need. So what we're going to do is just copy this section here and paste that into the document like that. And if you're familiar with DHCPD, essentially we're creating a subnet called the 10 network. Looks like we're doing a /24, and we're saying that we're going to hand out IP addresses from 100 to 200, with the default router being 1, and then we're handing DNS out of quad 8s from DIR. So very simple. Obviously, we could tweak this as we want. So when we talked about automation and everything else, this is really what it boils down to. You tweak these files, and then you can spin off a new VM that does an entirely different subnet. Or if you're writing this and you decide this one I want 192.168, this one I want 10, you could have 2 of these config files and tell it when it goes to build the Docker file to use one config file or the other. So it's what gives you a lot of flexibility. And for those of you that haven't played with it, this is essentially infrastructure as a code. You're writing code that will actually build a VM with a given infrastructure. In this case, we kind of do it. It's not full-blown Terraform like what Michael was using or playing with. That one builds up the full network and the whole 9 yards on different systems like AWS or Proxmox or any of these other ones out there. Much more detailed and complicated, but it can be done. All right. So that builds out our little DHCP file. Save that. The good news is, Debbie, once we get this all set up, that I just have a Docker container that you can pull. And so all this is already done. But again, I'm trying to demonstrate what it takes to build out these machines and not just pull some off the internet. Now, you as instructors, the whole goal is that I can give you examples that you can pull down, because obviously I know what it's like to be an instructor. Pulling down something and being able to tweak it a little bit, use it in the classroom is great. But we obviously don't all have time to sit there and build brand new containers and everything else from scratch, nor should you. You should be using other resources that are out there. So. All right, so this was our Docker file. Everything else should be the same as it was. We can just double check that. Go back into here. LS, and we got a DHCPD file now, and we have a Docker file now. So just to make sure everything's fine, let's do Notepad for the Docker file. That comes up over here. Come on. Nope, don't put it in there. Just, nope, stop it. There we go. Okay. And this looks good, but we can just double check and make sure we're not breaking anything that we had in there before. And it looks like it just cleaned it up a little bit as to what we would have had in there. And then we can go ahead and run that same build command and go from there. We could embed that config file right in the Docker file, which is common in some cases. If you wanted to tweak it, it's easier to have a separate config file, and then you just end up with a directory of config files. So a great example of that is this project that we're using, this whole framework thing that we're trying to build. That's essentially what they did, is they're giving you a GitHub repository of these extra little configs. You tweak them, and then you run a command, and it builds a new virtual machine based off that little config file. It's very much what like SecGen is, only it uses XML. Again, it's a little cumbersome because you have to go in and tweak these little files. And so my goal with Forge CTF is that you just have a website. You fill out a wizard. I want this IP address range, this, and this. And it will go ahead and build all that out on the fly. But it has a nice little click-through wizard that you can have, and then it will do all this stuff on the back end for you. Okay, so that looks good. Let's go and see if we can run our Docker commands again here. And that is to build this image. That looks better. So what this did was it pulled down that same image we deployed the first time. Now it's going to automatically do the whole commands that we did earlier: apt-get update, apt-get install. Then it's going to tweak the config file to make sure it's handing out DHCP. And so now that we've built that file, we could go out here and actually run it with one more command. And it looks like it's up and running, and we have this Noble one here. Now, my guess is this is failing because of the network and stuff that I have that associated with. I could be wrong, but let's see here. Let's see, PID, can't lease database, DHCP leases, failed database write attempt. Okay. So what that's telling me is it doesn't have write access to the files that we were creating. And so we just probably need to keep working with that Docker file to make that work. So let's grab this because that'll give us that answer. And again, we'll use our friend here. And so hopefully this is useful with you guys seeing this, interacting with the AI. That again was my point, was whether you use ChatGPT or one of those local LLMs that we set up, you can use this to try to help you figure out what might be going wrong under the hood. Let's see here. You've already got the file. Yeah, so this is telling us how we'd fix it, which is what I figured. It's just a permissions thing. We need to create those directories because they're not there by default. We would have to do that by hand, log in and do that. It won't quite work. We want that all to work in our Docker file. In other words, we wanted to take care of that when we tell it to build the image, that it should automatically touch those files and have everything set up. So I can just copy this Docker file, and this is the same one. So we'll copy and save, and we'll just rerun those same commands. Build a new image and try to run new image. Okay. I love how it comes up with the random names. And we're not configured to listen on any interfaces, which we should be because we had it out there. Interestingly enough, we told it to listen on that one interface. I'm going to say we use --net host working, so. All right, so it gives us two different options. We can either tell DHCPD exactly which interface to listen to, or if we want to set it in the default file, we could go ahead and do that as well. And then add subnet declarations. Let's see, you do want to serve DHCP on one of the container bridge, which we don't. So the whole caveat here is we're trying to, again, host DHCP on a system that is already doing that inside of Docker. So it's like Docker inside of Docker, and causing some problems there. So I won't necessarily continue down this path, but my goal is at the end, you would just end up with this quote Docker file, like what we built out here. And with that Docker file, you would just run those commands like we did before in terms of Docker run whatever. And that would launch a VM that we end up carefully creating here. And you wouldn't have to build it out from scratch. Does that kind of make sense, Debbie, on how to play with this? Or did I lose you entirely? Okay, great. Yeah, it's and that if you're new to Docker, I mean, like I said, we could spend a whole week training on Docker kind of thing. So there's a lot of this under the hood, but at least you understand the overview of the concepts of how this would work. The goal is that you pull down a Docker container, you run it, much like we did with our LLMs or our CTFD. CTFD is the same way. It has a Docker file, and all you're doing is saying Docker run that file. and it will go off, build the VM, pull it down to you, and be ready to go. Cool. Yeah, yeah. And like I said, everything has its place, whether it's a VM or Docker or something else. There's things you can do in one that you can't really necessarily do in the other. So they're all tools that we can use to build out different areas. All right, let me pull back up this guy here. And so it looks like it went ahead and built our VirtualBox image that we were looking for. And so if we come out here to VirtualBox, we should have a new image out there. Let's see if it actually did that. Let's see here. It ended up erroring out because of SSH. All right. Well, we are close here. It pulled down the ISO file. Looks like that all worked just fine. It was trying to create the hard drive. Okay, and back. So obviously I ran this and nobody got to see what happened there. So I'm going to rerun this command. And again, this is basically what happens in Packer. If we look at VirtualBox, right now you're going to see this image that's being ran. It's called Packer Testbed. And it doesn't have a head end. If we actually double click it, we can see it. And we can see that it's trying to boot that Ubuntu image. But what it should have been doing was actually interrupting Grub. It should have been telling it to automatically do this install. Instead, this virtual machine is stuck waiting for us to select the install. So it's not building it on the fly with Grub like it should be doing. And so we must be missing some commands or something that's inside of there. So what I'm talking about is up here, like it'll do a Grub installer telling it to wait. It passes what's called a pre-seed config. And for some reason, that pre-seed config is not doing what it's supposed to do. This is kind of the boot sequence of what that would look like. So when the virtual machine first boots up, it would wait for a few seconds, then it presses enter, it breaks into Grub, and then it goes ahead and adds the different Grub lines that allows us to do an automated install of Ubuntu. And because it's all headless, it never pops up on our screen. We had to manually go pull it back up. And then once it's up and going, then it ends up using Vagrant and Ansible in order to execute a couple scripts on setting up the environment for whatever this is. In this case, this was one of our little PLC boxes and that kind of stuff. And then at the end, it will end up using Vagrant to build out a quote box. And that Vagrant box is then what you can use as a mechanism to deploy out to VirtualBox. We could use it to deploy out to Proxmox, literally anything. Vagrant has plugins for just about anything out there. Again, this is the kind of stuff that is all built from scratch. And if you guys are into DevOps, that kind of thing, this is what they do all day long. Thankfully, most of the time I get to work with people that do this day in, day out. So they have all these nice little script files and config files for this. In terms of us building it, this is, again, what I've been trying to do. This is the part of SecGen that's actually broke. I know I keep talking about that project, but this is what it did behind the scenes. It built all this out, and unfortunately, it was severely broke. And they lost all their boxes. Nothing's up to date. And so I have to go back and rebuild these boxes from scratch and then tell their project to point to the new boxes, and then everything will take off working again. The problem is those boxes are extremely old. It's like Debian Noble. It's like Debian 7, Debian 8, and they're currently on 13. So way, way out of date. So it doesn't look like, unfortunately, JB, that we're going to be able to get this ICS testbed framework up because because it's 7 years old. I'm going to have to figure out exactly what's broke in their boot commands and stuff like that, and get a new one up and running. But I'll fork their project and see if I can't do that. No. we got to try, right? I mean, the whole goal was that we wanted to find an easy way to host a PLC controller, and we don't know until we try. So how do we want to sum up the rest of the day? I know we had other ideas and plans and thoughts, but if you haven't noticed, I'm getting a little scattered. So I would like to write down here exactly what we would want to accomplish this. And before I go there, I think the best way to do that is, Ravi, did you end up coming up with an image?
I have it sitting on a Proxmox. I have the Ubuntu VM in there, but I was not able to get I was able to get them to work to each other, but then they are not talking to each other within Proxmox, or they cannot pull them out.
Okay. Did
I
you
want
have like a topology that you were looking for? That's kind of what I was after.
Yes, the idea is okay. I was trying to bring up a topology file as simple as it is, but the idea is only one machine should be running.
Okay.
It has only 1 gigabit out, but the gigabit out is going to a switch.
Okay.
That's a good idea. Going to a switch, which then has has 2 VLANs.
Okay.
One of the VLANs is going out to the wireless AP or the wired router, whichever is available, towards other people who want to connect to it. So basically, device-wise, there is a switch, there is a router, there is a server.
Oh, gotcha. Yeah. Sorry, I'm just trying to
No
build
problem.
exactly
You're
what you're
doing
talking.
fantastic. I just needed to give you the boxes. That's all. Let's go with the physical, and then we can go with the logical.
Okay.
Yeah, the VM, the switch, and then there are router.
And then a router. Okay. And this router is connecting out for internet, or
This router is what will read out to a wireless AP.
okay. This is a physical
Or a
router.
wired AP, that's all. This could do both functions, but the point is, I just wanted to have 2 VLANs in there.
Okay. And as far as your VLANs, what are those VLANs going towards?
Okay, 1 VLAN is going to the server,
Okay.
and then the other VLAN is going out for internet access or anybody who wants to connect to it.
Which is basically coming out for the AP portion of this, right?
Yes. Yes.
Okay.
All of this goes on a deck or a pod or a little thing that is going on there. The VM will be hosted on a box. The VM will also the VM server or the server will host what is called as all the CTFT plus the actual vulnerable virtual machines, whichever they want to. At this point of time, I want it to be CTFT with OT. That's
Okay. And so that's what this VM is?
yes, exactly. Yes.
Okay.
Yeah.
So let's do this.
So it'll go to a switch and then to a router. And then to an AP to connect to the users. So everybody who's going to connect to it will connect through wirelessly through the AP.
Okay. And you did want these on separate VLANs, you were saying, is that right?
Yes, yes, yes.
Okay.
So yeah, that's at this point of time, that's where we are.
Okay.
I want to put a little user in there so that I can test it. That's the Ubuntu user. The Kali would be the pen tester, so you can put Kali as the pen testing thing. Yeah, VM, yeah.
I'm just throwing numbers in here just so we visually see.
Yes, absolutely. VLAN 100 and VLAN 200 should be fine. Yeah.
Okay.
This is a sample thing. Anybody who accesses it, for example, in a classroom or a setup or anything that's going on, they would have access to what is called as a AP that's coming out. They can log in, they can get in there, they can connect to it. Once they're connected to it, they will have access to the vulnerable VM or the CTFT server platform.
Okay.
Only within there. It's not internet accessible. It is there. It will be running forever for whatever contest days that are there. That'll be there. That's all.
Okay.
client or student or anybody who's there. So that's the active pen tester.
Gotcha. And
This
these are all just coming in
will
here.
be the
So-
Jeopardy type learning thing that is running for them for all day long.
Okay. 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 I think I got the gist of this. It ain't pretty
Yeah.
in my regard, but I get what you're trying to say now.
Yep, yep.
And so the idea here is that this router is going to end up handing out XYZ subnet
Yes.
for whatever that may be. So let's say something like well, I did the opposite.
Yep, sure. 192.168 150.2 or 150.0/24. So that's the number there. You can
Okay.
use 150 for the CTFD website, and then we can make that the server that's accessible. Since we have a router in there, we can redirect it there. That's all.
And so these services will run on something different. Call it.
And Proxmox would host all of these VMs as we
Okay.
shared right now.
So the good news is obviously depends on what hardware box you end up choosing here, but a lot of this can be baked right into that box, so you don't even have to have anything other than a physical
The
AP.
general idea is I should go to every school or every place or every mobile unit as a little box that I carry with me around, as little as possible, about 15 pounds or size, with a pole. That pole is hosting a wireless AP that could be anything. And then the router and the switch will be smaller routers and switches that can be just set up inside the box itself.
Okay.
So this will be a mobile CTF platform.
Yeah.
That's
So,
actually-
I mean, frankly, there's no reason we can honestly do almost all of that in
Absolutely.
one box here.
That's the general idea. I have an Optiplex with about 32 gigs of RAM, 2 slots, 2 terabytes of space, and about 8 cores. I want to beef up the 8 cores to about 16 cores as possible, if possible, with an i7 or Ryzen 7, and that's about all it is. That's the box. The APs we have Ruckus APs, we have Cisco APs, or we have Uni APs, Unity AP, Unify APs. We can use them for that. And then within that, we can have virtual instances of each one so that we can separate them using the VLANs so that the firewall goes through. Firewall is the one that allows for the clients to get in, and then we go through the firewall and punch the hole for only for the CTFD server, and that's about it.
Okay. And so more than likely, like these will be an all-in-one box, so to speak, then, because you're going to use a hardware router / AP.
Yes.
Okay.
It could be a multi-unit, but I want to see if it is possible. As we expand, I can replace a router to be an active router that we can program, and a switch that we can actually program in a router and a wired one, and then use the AP as an extension.
Yeah. So because, I mean, there again, depending on what you do, I'm trying to think of how we could do that.
Right now, I can give you the actual hardware specs on this I have.
Yeah, because
So
ultimately,
yeah,
do you have a
VS
PCIe
box right
slot?
there. It's on the same line like this. Instead of 8 gigs, I have 32 gigs. I can run the whole 9 yards on that thing. It's a dual display. All that is fine. The BT Wi-Fi and all, I'm not worrying about it because I have grounded it out to a physical device. So it will run a gigabit line to the switch. Right now, I have a Cisco or a Unify switch in there, both the hardware I have. I have a Ruckus router or a Ruckus. I can have a Cisco router or a Ruckus router. I was trying with a surplus Arista or a HPE router. Those are all hardware that I want the students to actually look at. Otherwise, it's all unified. The AP is a definite Ruckus 650.
Okay.
So that's mounted on a pole with a little baseline, with a little box, an open frame box. That's all. So it's all on a pod, like mobile pod or kind of thing, so that you can just carry it out. That's all.
Okay. Okay. So yeah, you could actually use all that hardware, all of that, and then even down to like the smallest thing. So for example, Terry, there's one way that you could do something similar to what he's doing, but you could take, like, say, this box if you got it, and we would pass the Wi-Fi chipset into something like OpenSense, just directly pass the PCIe bus into a VM of OpenSense. And then you could pretty much do this all in one box where OpenSense would control the Wi-Fi out of this thing, make it an AP. And then your router, your switch, all of that would just happen inside the OpenSense box. So it becomes one box as opposed to other hardware for like your students.
All right, cool.
Okay. Yeah, no, this all makes sense. So if you've got Proxmox installed on your
Yes, that box has no Proxmox right now. It's sitting there, so it has Proxmox on it. It's not interconnecting anything. Next thing I want to do is that I want to connect it to a individual client. Forget about the switch and the router. I just want to connect to a client device and then make sure that it's accessible. And that's about the culmination of what I'm trying to get in and expand on that later. So,
yeah, absolutely. So I'm gonna pull up this one. This would be like you logging into your box because this is a fresh install.
Yep.
And no tweaks for my NetLab stuff. It's just literally a fresh install. So
Sure. Yes.
so with this, the couple things that you would want to do here is go to your network side.
Mhm.
And then obviously this has two interfaces, right? I've got my physical network up here, and then I have my wireless one. You can ignore that part. You get VMBR 0 over here.
Yep.
Yeah, that's no problem, Melissa. Let me double check here.
Yeah.
Sorry, I just want to make sure we got.
No
Oh,
problem.
yep, I got Chola back. There.
And my heart goes out to him. He teaches in the middle of everything.
So what we would want to do is create some sandbox networks. Now you can do your VLANs and that kind of stuff. And so in here, if you were doing that where you were just essentially passing the Ethernet port off of your box out, you would just come in here and do a Linux VLAN. You could say 100. And the raw device for this would be the ENP1S0 in this case.
Mm-hmm.
And we could call this the server network or whatever you decide to call it. Just give it something.
Yep. It's just a CTF black box or blue box. You call it that way.
Okay. And then we could do this other side, which would be our 200.
Yep.
And that would be something more like your client network.
Yes. That's the client facing network that's on the other side of the firewall.
Okay.
There is a firewall in there somewhere just between the router and the server.
Okay.
I want to make sure that there is a firewall in there, but then not for today, but that is there.
Gotcha. So let's do this. And I'm going to emulate some of that hardware, but you would obviously use hardware for these pieces.
Yes. We can, I wanted to, this was originally on a Pi based network. Everything was hardware, a Pi black box and a Pi pfSense and a Pi hole. The whole 9 yards was there, but then this is a little bit modified on that.
Gotcha. So then, yeah, you would just take the uplink out of this into your switch if you needed more additional ports or whatever else. And then you would obviously be able to peel those VLANs off accordingly within your switch off a trunk port. I'm going to slightly tweak this to where instead of these actually being VLANs, in other words, I'm going to follow more of what like Terry could do just because I can virtualize it.
Sure.
So for that, what we would do is just create a bridge, and this bridge over here, we could just call this server, and this will be our server network. And it's not tied to any physical networks, so it's just a separate subnet. And then we're going to have another one out here for our client. And this will be our client network. Okay. And so let's go ahead and apply that. So we have those two networks available to VMs. And so the first thing I would recommend is obviously you need your firewall, which you just said before. So for the sake of this little environment, I'm just going to use an OpenSense box.
Absolutely.
Something, oops, OPN sense.
OPN.
And we'll just grab its little ISO here.
The expanded idea for the VLANs was that VLAN 300 would be the OT network with the SCADA or a PLC physical device.
Oh, okay.
That's how it goes on to the physical realm of things.
Perfect. So I started downloading this here, but if you are on a Proxmox system, the cool part about it is it will, it's a BZ file. Of course it is. Okay, disregard. We want to download it.
Okay.
Let's see if I can find, do they have one in their mirror that does not have it compressed? I was hoping it wouldn't be compressed. Nope, they compress everything, unfortunately. Okay, well, Disregard. And there's clearly more lightweight things that we could use besides even OpenSense. But this is a good way for you to have a little router in there so that you can
Yep.
segregate those two networks.
This could also be supplementing for the SCADA part of things or the OT part of things. That would be the best part of going for it.
Yep. Yeah, you could peel this off into multiple networks. So a good plan, if you guys haven't seen this, what it looks like under the hood of even say NetLab, because that's a good example. When you guys had access to a pod for this critical infrastructure,
Yes.
these are all actual individual networks. So when I just created those two of the server network and the client network, there's actually on the fly, it creates 5 of these networks coming out. And then when we put these virtual machines on each one of those networks, and then this pfSense sits on all 5 of those networks doing the traffic routing between. But all of this is sandboxed. It's never hooked up to any physical link that goes out to the internet. That is exactly what I did here. I have a client, a server, et cetera, as it goes on down. And if you were to see like a pod boot up, that's what you would see that do. This is my dev one, so I can't show that. Let me see if I just so happen to have somebody on our system right now. Doesn't look like I have any students on there at the moment. Yeah, but if I did have students in here, if we went and looked at this particular host networks, for example, there would be there's actually a couple out here. A couple extra networks would be showing up, and those are dynamically created through a script, and then every one of these virtual machines is then associated with the appropriate network, and then it comes on back to the next one. So that's all what the automation of NetLab does, but we are just going to do this as a one-time pod kind of thing. So we don't necessarily need that extra layer of depth, but it'd be handy if you had multiple scenarios on your box, right? You turn on these and they fire up on their own networks, everything works. And then if you want to run a different CTF with different VMs, you just turn on these VMs. So. All right, our Proxmox is almost done. Or, I'm sorry, not Proxmox, our OpenSense. And thankfully, normally, like I said, you would just download this straight to the Proxmox host. But they actually zip this file, so we got to unzip it and then we can upload it to it. Although it's possible that it actually allows you just to do it straight on here. So let's see here, summary. I'm just seeing how much storage I had left on these. Yeah, I got pretty good. So let's see if it actually downloads it directly like it's supposed to, which is actually a pretty cool feature when it works. You can query it. Ah, yes, of course it did do it directly. So you could just pass it a URL of an ISO image and Proxmox will go out and grab it. In this case, it's going to go ahead and unzip it and do all that stuff for us. So we'll let that go ahead and do its thing. And so while it's doing that, there's going to be some other images that we're going to want along the way. We could go ahead and just grab an Ubuntu server image for this point. What that was live server for the other one. We don't want Jammy Fish. Let's go back. And it all depends on what you want to run with those virtual machines and whatnot. You said you wanted CTFD and some other ones, right?
Yes.
So I would say for the time being, we could just grab 24, actually instead of server, just to make it easier for us to interact with. It'd take a little more resources, but let's use the desktop. So let's go Ubuntu. Let's download now. Should get us the ISO. Great. And so we can just right click and copy this, go back to our Ubuntu box. I'm sorry, our Proxmox, do another download from URL, query, and download. And so that'll start downloading that ISO to the system so that we can build out an Ubuntu desktop image that will have Docker desktop on it for us so that we can visually be able to launch some of these packages for you.
Mm-hmm.
There's obviously much lighter weight ways of doing it, but when you guys are developing and learning, it's nice to have a GUI to do this stuff.
Scaffolding is quite necessary at this point of time to make sure that
Very much, right? Very much. So ultimately, what would be nice is, you get this and you have 2 scenarios or 3 scenarios you want to run. Then what you would do is build like a little web server. At least this is how I envision it when I was doing it for my students. I built a little web server and they would go through and pick which scenario they wanted and hit build, and it would go off in the background and launch the appropriate Docker containers and or VMs, etc., get the network and everything configured, and then say ready to begin at here. And it gives them a URL that they could then start at. At that point, we may just an IP address that they can scan with a Kali Linux box or something like that.
Oh, yes. That's kind of a step 32 part.
Right. So, and since we're grabbing images, we might as well grab a Kali image here as well, which we started to get set up early, but to have this little self-contained pod that you're talking about.
We can run it on Proxmox NB. So.
Yeah. So what I'm doing here is I'm going to just emulate you already having that wireless and all that stuff set up. I'll put Kali on the client as if it's on the client, and then we can test everything.
As long as the server is up and with the VMs, as long as we can have a client ping it up and then look it on, then we are game on.
Perfect. Okay, OpenSense is almost done, and then let's see. Nope, that is not the correct one. Yeah, of course it's 7-zip compressed. When we get to the Kali box, we'll just transfer one across is what we'll do.
I'm having a Kali box separate, and that's what this whole thing is, clickety-clackety thing is all about, getting into that thing and then trying to upload it. So let me pop this question here.
Yeah.
Docker desktop is fantastic. But what about Podman?
So Podman and Portainer are very much similar. They're just there for orchestration and in order to give a GUI to that. I personally haven't used Podman, and I tested it a long time ago, and there's nothing wrong with it. It's just whichever one you get used to.
Okay.
That's the way it boiled down. So there again, you could use Portainer on this little guy if you wanted it for a UI. Podman, trying to remember what Podman was.
Podman is similar to Docker.
The Docker desktop side, right?
Yes, but it's also KubeReady, and VS Code integration is also there. So
okay, yeah. I had the Kubernetes stuff right there. Gotcha. Yeah, there again, I learn all these tools and then I forget them pretty easily.
These are now used by more data science and data dashboard people, so they are trying to get it sorted out in there. So
yeah, this makes sense because you could just build your files and stuff on the
fly. We're
fly.
talking about the NDG terminology. That's what I was saying. Like, you can podify containers into a setup. So if I can have many containers and then make a pod out of them.
Yeah, and I think what this ultimately does, if I remember right, their reference to a pod is very similar in that approach. It would be like a Docker Compose file is ultimately what it would end up being. Um, where you could spin up the whole thing at once and go.
Okay.
Yeah. I can't remember. Is this one, it is open source or not open
It's
source?
open source technically. There's a community version of it and all that. So
Oh, great. We'll just install it right on
yeah,
the virtual machine.
sure.
No better way to learn than now. So
Yeah, right.
okay, it looks like it's got those two done. So let me refresh here, and we have our OpenSense and Ubuntu. So let's go and just create a new VM here. And we'll go to create VM. And of course, these IDs don't really matter at this point. You can
It's
organize
all
them.
configurable, so it's just a test part so that we can, when we go from the blue to the green, we can actually make that modification to live.
Yep, absolutely. And so we'll call this Ubuntu server for simplicity's sake. We'll point out to our Ubuntu. Oh, I called it desktop. Sorry. There we go. Something that makes sense for us. And we got our desktop on system. We'll want to have this QEMU agent marked because we'll install that once we get up and going. On the disk side of things, we probably want to give that much more than 32 gig.
Absolutely.
Default for me is always 100 gig. We can always resize it.
Yep. That's why I popped in a 2 terabyte in there. So
Yeah. And you would want the disk card IO on. That tends to help, especially if you're running on SSDs. CPUs, you're going to need a minimum of 1 and 2 on the cores. You might end up wanting more if you host a lot of Docker containers. On the type, it's always recommended to go to host unless you have issues, and then you can fail back to x86 64 v2 AES. But host is always preferred. Memory, we're definitely going to need more memory since it's a desktop.
4 gigs is good. Yeah.
Let's see, network. And so obviously here, we're going to put this on the server network for now. I'm actually going to bounce this out to my VMBRO because that has internet access because we need to install packages and stuff.
Sure.
So for now, I'm going to put that on there. We could add a second network card that we could turn on for the part of install and then turn it off later.
Right.
That's actually how I like to do it. In which case, we'll leave this on server. Just hit next for now. Burn. And we should get a nice little container over here. Or I'm sorry, a VM. We'll go back to hardware and we're going to add a second NIC to this. And that one we will put on here.
Yep.
And then so for the time being on this one, we'll go to edit and I'll give you, yeah, there you go, disconnect. And so that just makes sure that it's not connected for the time being. We'll flip-flop those when we're done. Okay, other settings that are pretty common that we like on Proxmox. This all looks good. Nothing on the drive. Options, and it already has the boot, and we have our QEMU guest agent. Go ahead and double click on that one and click the checkbox for guest trim. That again, make sure things stay nice and clean when we transfer it around. Okay, so we at least need to get this up and running. So we'll go to summary. Oh, one other thing I've noticed with newer desktops, if we go to display and on this memory, we need to set that to at least 64. On the graphics card, I like to make sure that we use Spice. That's kind of a NetLab default. You don't have to use Spice. If you don't use Spice, you could just use standard VGA, but Spice gives us some extra features. And clipboard, I like to make sure is VNC because we might want to copy and paste stuff in the virtual machine. And so having that option checked is good. Okay. So we go ahead and hit start and launch our console. And it's going to try to open Spice. Instead of that, just click the down arrow and go no VNC. And that will get us started. All right.
This I remember.
Yeah.
Yeah, the last part is like it takes a while for you to get this thing sorted out, not in Spice, but no VNC, and then we have a VNC server in there. We have to set it up.
Yeah, and the old school ways. Yeah, absolutely. And so what you could do is if you're going to give them access to these images, obviously they're coming from their laptop or something like that, right? So they would need Kali running on their laptop to have access to that wireless network, something like that. So they had some tools. If it's just a simple Jeopardy style CTF, well, then obviously they don't need extra tools.
Want this to be K through 6 to be Jeopardy style, and then about that. That's why I was like looking at it limited 100 200 VLAN, so that when that switch comes in there, that switch is going to connect to other devices, other VLANs that can then take in what is called as a SCADA network or a Proxmox with more devices that are on a separate VLAN, so that you can go and access them through the server through a different access.
Perfect.
So this would be the baseline for them to deploy.
Yeah. Yep.
If I give it to a high school educator, then that's going to be a little bit of a stretch for me to have a huge, run up instruction file for giving them like turn this on, turn this on, turn this on, and it'd be a little difficult thing. So
No, I hear you. And that's what I mean is once you get this all set up, then you can really streamline it where it's a plug in, go to this URL and hit start kind of thing.
oh yes. If I give them as a box, they would be happy to have the box, and then that's
So again, we're installing Ubuntu Desktop purely for the fact that it gives us some kind of GUI to learn and get this all set up.
Yep.
Long term, we would definitely want this to
As the initial saying goes, for the scaffolding part of it.
yeah. And you definitely want to make sure you stay with the defaults. That way we're not bloating this image up more than we need it to be.
Yes, that's the thing.
And we can call this whatever. So I'm just going to do sysadmin, something simple for this image. Server. You know what? Yep. I'll just build this out because this is one that I'll turn over to you guys when we get done here. Why did I pick Denver? I'm not in Denver. That's what happens when you click too fast there. Okay, so this one's obviously need to go ahead and install. While that one's doing that, we can simultaneously work on our little OpenSense firewall box. So coming back over here on this host, we will create another VM. And there is some caveats to the OpenSense. I'm going to try to remember all of them. Well, that's not what I wanted. So name here, we would do OpenSense for now.
OpenSense, yes. It's basically firewall. So.
And we got our image in there. And so let's see here. OS, we would go ahead and point out to that one. This is a little easier in pfSense because at least we're Linux based and not FreeBSD based. That gets a little more difficult inside Proxmox. It can be done, but it's a little more difficult. This all looks good. We may need to tweak our kernel, but for the most part, that should be fine. Again, let's throw our QEMU agent in there. And this one doesn't need to be too terribly big on the drive. 32 is probably fine for what we're doing here. We'll add discard. 2 cores. And again, we'll set that to host. Memory, 2 gigs, fine. We probably don't even need that much, but that's enough to get us started. On the network side, we'll end up needing multiple network cards, so we'll just add network for client for now. And we can hit finish. Okay, that one's still going. And so with our OpenSense one, there's a couple things we'll need. At minimum, we need 2 networks, right? We need a in and an out kind of thing. So network device, this one would be on the server network. Oh, it's going off here. Supposed to be on silent. So server looks good there. That's
Well, I
right.
just downloaded OpenSense and started popping it in. So
Perfect. So we got that one up and going. We got our cores, everything set. Options, again, QEMU agent. Make sure we add that little trim section. Everything else should be fine for now. Summary, start, and console there. This one, we don't need to worry about setting up the GUI because it won't have a GUI. It'll be a web-based GUI when we get in there. So let's start up the default here. Great. We don't want to interrupt for the importer. We're just going to let it do the base install. We will go ahead and hit the enter key here just to set up our interfaces correctly as we're coming up.
sure.
So do we want to configure the lags now? No, we don't want any lags. VLANs, for this sake, we won't necessarily do it because it'll be an in and out. We don't necessarily need VLANs. Those are our 2 interfaces. And so we have VTNet 0, which is our DO. That should map over to our first NIC. And so that one for us is set to the client side. That'll be the.
I don't know if I'm the only one that lost my volume.
Anybody else lose?
Okay, I think I hit a button. It's working now. Probably just
Oh, okay.
me.
Yeah,
It's
no,
just-
no. No problem.
Oh, this is rich. I'm just
Uh,
adding on this. It almost feels like, okay, this is good.
Okay, so it wants to know our WAN interface. In this case, we're going to set the network side as our WAN interface where the server's being hosted. So that would be VTNet 1.
Mhm.
And then LAN interface would end up being VTNet 0.
Yeah.
This time we don't want any extra interfaces, but we could do that down the road. That looks good.
Wow. Not happening on the fly. Okay.
And it probably would have been best if we flip-flopped them here, just so it made more sense in the OS. We'll see. Sometimes that is right. Sometimes it makes it a headache. Either way will work just fine. And of course, it's trying to pull a DHCP on the WAN right now, and there is nothing because it's going nowhere. So it just has to time out, go through its paces there. Now, this install is going to take a little bit because this is on that little tiny Beelink box. I decided to do that just for the purpose of the demo here. So it's obviously not screaming fast, right? It's a little N95 proc, super low wattage. I mean, this thing doesn't even pull.
The N95 has a notorious reputation, by the way, for being the successor to the Celeron.
Yes. This one, honestly, I use them because they literally run at 15 watts. Like on a high end, it'll go to 20 watts. That's it. So, very, very nice. I use them for display TVs and stuff like that, advertising. But okay, so we have a login here, and this is where we're just trying to get the installer to go up and go. So what we want to do is just log in as root.
Mhm.
Or I'm sorry, not root. Installer.
Yeah, you're the installer, not the root.
First one. And password is, I'm trying to remember. I should know this. It's just password. No, it's OpenSense. That's what it is. Installer, OpenSense. There we go. And we're just going to use the defaults. Nothing fancy here. Let it use ZFS under the hood. Yeah, and that's because it was trying to use ZFS, which probably, let me go back here. Sorry. We'll go back in here. Installer. There's no real reason for ZFS, so go ahead and use UFS. That would be the better choice on this case. It's still wanting to do. Okay, it's fine. We'll just proceed anyway. Okay, so it's wanting to know what disk we want to install this on. This would be that simple little 32 gig disk that we have in there. And you can use a standard defaults on everything. Looks like our Ubuntu desktop finished at the same time. So we'll just go ahead and restart that guy. Enter, get rid of our little ISO on that guy. Come over here and edit and set to none. So the goal here with this little desktop machine is I'm actually going to get it all up to date, get it spec'd out, and then we're going to end up cloning that and setting it as a Proxmox template because we're going to use it in a couple of cases, and it's just a basic install at this point. So we could change things after the fact.
Absolutely. Could be a server, it could be a SCADA conduit or a MQTT dashboard.
Absolutely. Yep. So that looks good. This is just the silly pro stuff. Okay. And so one thing I always like to do on these, get up terminal, go ahead and pin this to the dashboard so that it's always over here on the left. And we'll do an apt update. Oh, sudo. Oh, okay. Okay, and then an upgrade. It's good. Race to see which one ends up finishing.
I go into the Ubuntu and then I start setting up the updates. It's like forever.
All right, so this wants us to change the root password. We should probably do that to get started. course they did. Okay, I can't type it wrong that many times. There we go. Okay, so this one got its update, and we could do a dist update or upgrade, sorry. Grow-Y, so I don't have to press it. Looks like everything's good. And we could do a auto cleanup. And that just cleans up any extra stuff that may be out there. So this one should be up and going. What we're going to do is just exit out of that one. We'll go ahead and shut this one down. And since this one's done, we'll go ahead and complete that install and reboot. And as that one gets ready to reboot, we can come to it and disable the CD-ROM. Need that for booting anymore. All right. And so our Ubuntu desktop's down. Again, we're going to end up turning this into a template so that we can use it for a couple different cases. So I'm going to end up just cloning this to make it a template for now. Give it a higher number, and Ubuntu desktop template, temp for now. And of course, that'll take a little bit because that's a big file. It says 100 gig. It's obviously not 100 gig as we go through there. That was just the size of disk that we gave it. So keep an eye on our OpenSense box. It should be booting back up here. Again, it's struggling because it thinks the WAN is going out to the internet and that kind of stuff. We don't necessarily need it to do that. For the sake of this, I am going to go ahead and just kick it out to the internet so we can get it updates. So on this one, I go to OpenSense and the network for server side, yeah. Pass it into my VMBRO, which is essentially my management network for the Proxmox server, which has internet access. It should be able to pull a DHCP and go out, which it looks like it's doing. All right. And so because that worked on the WAN side, it obviously pulled something off my management network. And then on the LAN side, it gave it that 192.168.1.1. So we'll be ready to log in via the web. We could hit this IP address and go, but we have to have something to log into it on the web with. So that's the reason I wanted to get this clone out here going for the templating side of things. Like I said, this system's a little sluggish for doing all this on, but that's all right. Okay, so I have this little temp. We could go ahead and go into the ISO. It should have none. Great. Everything else looks like it's set up the way it should be. So we could right click on that one, convert to a template. And so what that would allow us to do with that template is you can no longer treat it like a virtual machine. So I can't modify it. I can't power it on now. I can't do anything else. It's just a fixed template. In Proxmox, that would allow you to do like a link clone. And that way we could share the drive between multiple images. That way we weren't duplicating efforts and taking up twice the storage, that kind of stuff. In my case, I just wanted to have it as a fixed machine that we can use for other purposes. So this one's Docker. We can just power it back on and we'll use it as such. And then let's see here. For that, we're going to go ahead and hit edit, take this VMBRO. We're just going to take it off. As a matter of fact, I should have shut that and deleted that before I converted it to a template, but that's okay. Okay, we should. Yeah, I missed a couple things before I did a template. Oops. Got ahead of myself. So let's fix those real quick before we use our template. I'm going to end up just deleting this guy, unfortunately, because Won't do me much good. All right, like I said, OpenSense is good to go. What was that one? Yeah, Robbie, what you got?
Yep, I just wanted to say that I'm trying to replicate this into the Proxmox box. Yes, I ran into the issue with the not with the space, but with the Ubuntu VM. So I'm trying to see if it is. I have one question. This is something that I'm going to be continuing working on as I track with you. So once this is done, would this be available as a download as a package to download and drop into
Oh yeah.
device?
Yeah. So anything we build here in the Proxmox side, like I said before, I'll build out I have a Proxmox backup server. And
Sure.
so what I'll do is just give you credentials and you can hit it remotely from wherever. And then on your side, you would just come in here, click on your data center,
Okay.
storage, and add Proxmox backup server. I will give you this information
Okay.
and it will show up as a data store down here. And then the beauty of that is you can do something like this, call it PBS, whatever,
Yeah.
backups, and click on those VMs and it'll pull it right down to your system.
And then it's just image download and then deploy.
Yeah, exactly. You actually just hit restore and it will pull it back as if it's a VM on that machine. So you would hit restore, tell it what VM ID. If you want to change the name, you could, and boom, it'll pull it down and it's ready to power on.
All right. All right. All right. All right. I'm going to prep this and see if this is doable, but if it's that's halfway, then I'm going to get this out and get a little backup there.
Yeah, no, that's no problem.
Thank you.
As a matter of fact, like here, I'm doing it on this little box and it's struggle busing at the moment.
Yep.
Let's see if I lost just the connection. Nope, it's struggling. So what that means, Terry, is can it be done? Sure, if you're using the lightweight stuff. For development, it probably doesn't have enough resources with only 8 gig of RAM and that really low power CPU. Does that answer your question as to whether or not we can use this guy?
Well, at least we know now, right?
Yeah. I mean, if we did everything lightweight with no GUI and everything else other than just logging into a web browser to say go, I think it could handle it. But if we're doing all this development stuff, that's a little rough.
I knew we were here to experiment and try things out, so I'm good with that.
Okay. Let's see. If there's a point being, I'm going to just stop this VM.
I think everybody's on par with the same idea that we can reach out to you and like help with this, or what do you think about this, or that kind of stuff.
Oh yeah, absolutely. Absolutely. And that's something, like I said, I'll have over there in that Discord channel. So when I get that PBS up, you guys will be able to ask for an account. I'll just create an account on there and you guys can pull stuff down, that kind of stuff. Later on, I'll have a website with sign up and all that stuff. I just, for the sake of time, we'll just do it through Discord. That and I can do an all in there, and that way I catch everybody. It'll probably be a little faster and easier than email, to be honest. So you guys can kind of plan on that. If you just join the Discord server, and then when I get that all set up and running, I'll send it out to everybody. Let's see here. Try to power this guy back on one more time. And we're coming up on the 3 o'clock hour, so almost time for another break, but this should get us at least this little scenario laid out with CTFD running at the very minute. So yeah, I hear you, Reese. I could use some coffee myself. My energy drink fridge is on E. It's time for the next shipment of cases to come in. Okay, so this one, the other thing that we need to get done that I forgot earlier was a sudo apt install emu -guest -agent. That gets us up with all the ways for Proxmox to handle it like it's supposed to. So there we go. And thankfully, on new virtual machines, this goes pretty easily. It's on the old stuff that doesn't work well. So you have the QEMU guest agent. You also have Spice. Of course, that's escaping my head. So give me a second. Nope, that one. I've only done a ton of these here in the last 2 months, but brain is fried. Okay, it is Spice VD agent. And again, I'll get this all out there on a page for you guys. And it's already installed anyway. And then WebDAV D. That one just allows us to mount file structures and stuff like that down the road. Those are the three main packages you always want to install on your virtual machines inside Proxmox. You always want that guest agent in there. You always want the Spice VD agent if you're going to do any kind of GUI. And then it's optional to do the WebDAV one, but I encourage you to do that. There again, if you were to ever share this out or get this out on a NetLab system, it'd all be compatible. You wouldn't have to make changes, things like that later on. Okay. So now that we got those packages back in, there was something else I was going to do. Oh, I was going to delete that other interface by default. So let's do exit. Let's shut this down. Okay. Perfect. And then I'm going to delete the extra network interface and just leave the one that goes out to server. And we'll reclone that back out. Oops, I meant to put that as 999. Oh, well. All right, so this is going to take a little bit to do a clone. While it's doing that, we could take that 15-minute break, let everybody get their coffee and whatnot. And we'll come back here at the 3:15 mark. Zoom the recording. Yeah, no problem, Debbie. No problem. So I just moved over from that little devs or that little guy system over to my bigger dev system just for some speed. Yeah, I hear you. I'm sorry, Rita. I can hear you. I moved that over. I created that template that we were talking about before. And then on the Docker desktop, I just cloned that off one more time to give it Ubuntu client. And that was just so that we have something to kind of play with moving forward. So if we look at the hardware for my client, obviously we want to change that network over to the client network, which doesn't exist because that was on my other host. So let's go create those. On this host, we created this CTF, which we can go ahead and get rid of. And we'll create our server network. And we'll create our client network. Great. Okay, so we got those two in there. We'll go back over here to our client, obviously dump it back onto the client network. And that's great. Before I forget, you got to come up here and you got to hit apply because I just about screwed that up again. There we go. Okay, so client, that looks good. This Docker one will end up being our server. It's on the server side, and our OpenSense is going to end up being between the two of them with our client network on 0. And the second one, I believe, is our server. I may have flip-flopped those yet again. We'll find out shortly. Okay. Let's see here. So we'll go ahead and power this on just to make sure that I have it on the right network. Same way with the client. Go ahead and power it on, make sure I got it on the right network. And then our OpenSense, we'll go ahead and power it up, make sure it's on the right network. And we'll open up some consoles, make sure our consoles are working. So it looks like we're good here. Looks like I'm getting a double cursor, which I can fix in the settings here. There we go. All right. Get that one up and going. Let's see, client. That one going, and our OpenSense. Make sure it booted up correctly. Yep, and of course on the WAN, it's again looking out there for a IP address. One thing I'm going to do with this, just for the sake of, depending on what you may end up doing, Rive, you may make something similar. So instead of making my server network the WAN, what I'm going to end up doing is powering this guy down just for the moment. Okay. And let's do it now. I just want to make sure these other boxes came up. Looks like that one's still booting up. Client's fine. Okay. All right, OpenSense shut down. What I'm going to do is I'm going to end up changing this server one. Instead of it actually being the server side, I'm going to end up making that a true internet connection for the time being. And then I'm going to add another Ethernet interface that would actually be for the server side. And we'll map that inside OpenSense. I should have done this from the beginning. But we'll map that across. And that way, if we ever give internet out to the internet interface on our router, then it could go out, and everything underneath of it would get NAT, etc. And if we don't want internet, we just shut off that interface and it doesn't go out to the internet. That's typically how we do it in like a NetLab environment. But I got, of course, all of this clear out of order, so we may have to fix a few things. As a matter of fact, to pick things up the right way, let's do this. I'm going to take this one and put it on the internet network. We'll put this one on the client network and the last one on the server. Okay, great. And then we're going to reconfigure OpenSense to make sure that makes sense. So for this, we'll do our root. I think I actually didn't set that where I thought I did. Nope. Super secret password there. There we go. And so we'll need to reconfigure those interfaces. It's pretty simple. We just do a 1 for assign, no lags, no VLANs for now. And to match these up, we can see with our MAC addresses up above there. So now VNet 0 is going to end up being our WAN. So VTNet 0 is going to be our WAN. Our LAN, we want to be that first network, should be the BD one, so VTNet 1. And this optional one is going to end up being the B7, so VTNet 2. And that looks good. We'll end up naming those separately a little bit different inside the OpenSense box once we get the UI up and going. And again, this is handy during development. If you got to pull more packages or whatever else, you simply turn on the interface. And if you don't want internet, you just shut off the interface. So, okay, this looks good. Let's make sure that we have internet just to make sure. We're good. 8's going down, but we also don't, I don't know what interface that's trying to ping from. Looks like we got DHCP on that network as we'd expect. LAN is set to 111. And then on the op network, we haven't configured that, so we should be good to go. Okay, that all makes sense there. So let's go ahead and do a 6 to reboot. Yes, we are. And let's see how our other VMs came up. Not sure why that one froze, but we'll try it again here. I probably didn't reset these VM IDs, and that's probably causing part of the problem for the first time booting up would be my guess. That should be all right. It'll come up this time. Yeah. And this one is just our client. We're going to treat this like the laptop machine. So just so I don't get lost, I'm going to change my background here, and we'll just make it a flat color or something. Let's make it the bad ones there. Now, normally the best idea is to always make this a flat color and not a gradient or anything. It makes it a little easier for the students to access, but we'll just call it black, and that way we can distinguish between these two. Okay, so this one will end up being our desktop or Docker setup. This will be our clients. For now, on the client, we're going to go ahead and pull up a web browser. And this should be our 192.168.1.1. Client, just make sure I got that set up right. Client, going to client. Link down. Let's fix that. I had that one turned off. Undisconnect. Go. And we should be able to make sure we have an IP address. Looks like we're good. Just check it here. And we do 1.16. Okay. So let's try this. Great. So this will allow us to log into our OPNsense box. Make this a little bigger here as we work on it. And it resizes automatically. So let's do. There we go. And here will just be root and whatever we set up that OPNsense box with. Somebody on our Discord on this side. Nope, that's a separate one. Okay. Now we can kind of walk through the wizard here, although we pretty much have it set up. Host name, we could leave this as defaults for the time being, time zones, etc. Whatever you want your log files to be. So I'm just going to leave it at UTC since we're going to share this out. Let's see. On the WAN side, we're just going to leave this as a DHCP setup. And depending on what you're doing, you may want to unlock these because unless you have a true public IP address on the outside, this can cause some problems with double NAT, which is essentially what's going on in my network. So I'm going to go ahead and leave those coming into my WAN interface for now. On the LAN side, we went ahead and set up this network. If you want a different IP address scheme, we could do that. I don't remember what we had set up on your side. This would be the client side. I think he said 100 if I remember right. So we'll just set that to 100. And our root password, we're just going to leave that the same and apply. And I'm guessing we will need to pull a new IP address since we are on that site as well. So to double check that that actually configured what we would expect, we'll disconnect that wired, reconnect the wired. And we're now got a 100 address. Great. So that all looks good. We'll go out here to our interfaces and on this opt1, it pulls it up here. Oh, I'm in the wrong IP. It'll now be 100.1. There we go. Okay, so opt1, this is actually going to be our server network. So we're just going to call this server. Makes it a little easier for us to know what that truly is. We'll prevent actually removing it from this side, and everything else looks good. Apply those changes. And then LAN side, we're going to end up just renaming that for client, make it easier to match with everything that we've been doing. And then our WAN side, again, we're just going to prevent us from accidentally removing this interface. We can leave everything defaults there. Okay. From the very basic side, we want to be able to give ourselves some NAT in order to go outbound. So if we come up here to firewall and then to NAT, and we'll do a basic outbound NAT, and it looks like WAN source from client is able to go out. We could also tweak this just a little bit to create one specifically for our server network if we need it to go out, which we do, so we can get Docker and everything else installed over there. So I'm just going to do a manual. And we're going to say that our interface of WAN source is not going to be a source address, but sorry. This will be a server net. So we'll start with client net for now. Anything outbound, go ahead and translate to that interface and hit save, apply. And we'll add another one for our WAN source address of server. I believe that got those set up correctly. This interface is a little tiny. No, that did the opposite of what I was hoping to do. Let's go bigger, but not too big. That'll work for now. Okay, so source address going out, client server, that should allow us some outbound NAT. And it looks like that's good. And to make sure that that works, we come out here, we should be able to ping Google, which we can now do. Everything seems to be good on that side. We come out to our server, we can do IP add, and you'll notice we have no IP address on the server side, right? And that's because we never really set up a network on there. So if we come out here to our interfaces and our server side, and on our IPv4 config, we're going to do a static. And this will be a, what did we end up saying there? Is this a 16 network? Is that what we decided? Something random? That'll work. 172.16.0.0, and we can do a /32. Or I'm sorry, a 24. And this will be a 1. Like that. And then if we want to hand out DHCP on that side, we could do that too. Even though we would more likely want everything to be static on that side, we'll go ahead and just hand out some IPs for the time being. And let's set our range to something like 100. To 172.16.0.200, for example. Okay, and we can go ahead and start that service. Unless I missed something. Looks like it's there. this here. Give me a second. Got a couple DHCP servers, so I probably clicked on the wrong one, to be honest. Give me just a second. Yep, I did. So this is the other DHCP server. Nope. Yeah. All right, let's go up and use the one that they use by default. So if we go to general and client there, you should be able to also add server network. And all the other options look good. We'll apply. Host, domain, DHCP range. And on this one, we're going to add a server network. Everything else looks good for the time being. Okay, we'll do it that way. Okay. All right, that's a good start. And then if we come over here, back over to our one here, let's see if we pulled an IP. Not yet. We may have to tell it to come up. Aha, we had it still unplugged, so we got to fix that. So we come up here to our Docker, network device, edit, undisconnect, we're on the server, hit OK. And if all went well, we see that it has nothing there, but let's see if we got an IP. And it looks like we did. And can we get out to the internet? No, so we just need a route. Close that guy. Oh, I know why. So now we need to make sure we have a firewall rule that allows that traffic to pass out the server side. So by default, it has rules that allow anything off the quote LAN out to the internet. If we go out to the WAN side, we can see nothing allowed coming in. But if we go to the client, which is quote the LAN, we can see anything from the LAN is allowed to go anywhere else. We also need to set a similar rule up here on the server side. So anything that comes from here out, we can go ahead and allow. That one needs to be a little tighter there. I meant to do a source. There we go. Source coming from the server net. Great. And so that's going to allow traffic both to the internet as well as over to the client network. Now, right now, we're leaving it wide open. This is something like, Ravi, you may want to limit some of this stuff down. Obviously, you can put much tighter rules in, and that would work fine too. So if that worked, there you go. We have access out to the internet now, and we should be able to start configuring and testing some things. So we got our client. Again, we're out here to go out to the internet. This all looks good. And so hopefully everybody understands the topology at this point. Tell you what, I'm going to cheat and use PowerPoint because it's easier. Let's do a new slide. And so we have our PS or our OpenSense, which is acting kind of as our firewall router. It will allow us to go out to the cloud. Cloud here. Yeah, it's close enough. All right, so that goes us out to the internet. And it has the WAN link that comes out for that side. And then from there, we have a server side that comes out, and we have a client side. Now, you could do that if you just have one physical interface. In this case, you could do that with a trunk link, which is kind of what Ravi was talking about. But because we virtualized everything, we can just use multiple interfaces without having to have that side of it. If you wanted to come into this network, the great part is you could still do that. What you would do is bring in your trunks like you were talking about, and you would just replace on this host. Let me get the right host up here. Too many hosts up. You would just end up changing your host networking to, instead of having these sandbox ones, to go out to certain VLANs and tag it out to the physical interport or the physical Ethernet port. And that would allow you to have access out to your switch, which then you could have a bunch of physical PLCs or virtual, whatever else you wanted to interact with physical gear. And then outside of this, we have two little simple boxes right now. We have a server out here, which is going to host like our Docker stuff. And then we have our clients that are hanging out here theoretically off the AP. And that would connect back in on this side, right? That is a crude drawing, and I apologize, I'm not Picasso. So let's go back over to our host. And this looks good. Docker, pull down. All right. So we talked about using Podman. Was that right, Ravi? Is that what you were looking at? I think that's what you had said we were going to use.
Yep. Okay. Yes. We were trying to set up Podman as well on that because we wanted to see if it is Docker possible or Podman possible, because that's the setup. So, but then I was thinking more on getting into running it off of Proxmox as a server, so we can join it with NetLab and offer it remotely. So we had, the initial thought was multiple, but for this process, we want it all as a box, one box. So Podman on the box.
Okay.
Run it through all that particular jazz. That's all.
Yeah, so honestly, what we've created here is literally what I would do for a NetLab pod. Like, it would all exist within a pod with no internet access unless we turned on the interface on pfSense. Yeah, I built this all with NetLab in mind, man. I'm sorry. I can take what you're doing, but it's going to be compatible with NetLab, so I can use it.
There is a distinct way of MO, and this time it's a convergence that I wanted to do it on physical devices so that we can have an out on the physical devices. I do hear about a possibility for NetLab having some access to IoT devices that can be added to a NetLab functionality for testing IoT access and pen testing kind of scenario, but I don't know about the reach of it. That's why I was like saying physical IoT devices can always be had a PLC or a controller, maybe even an Arduino kit in there, so that we can have a second line in that functional diagram that you're presenting on that PowerPoint deck that had server, client, OpenSense, and internet, right? That OpenSense and these are all connections. Now, in between that OpenSense and there you can add a physical SCADA network right there next in between OpenSense clients and server Docker, right there. That's a SCADA network right there. You can get a PLC in there and say that that's the physical device. So that's what the uniqueness of it. We can go to a different location and maybe move this SCADA network into an actual click PLC and then make it a PLC network so that they can access. Once we have the IP addressing set for that, and then everything goes through the server, boom, they're all able to, clients will be able to access and actually hack it through. And it represents a more flexible representation of actual physical network hacking, which is an actual skill component in the KSA pathway. So that's
absolutely. Yep. And what we're redoing is essentially we're recreating this topology, right? If you look closely, I use pfSense. This could be your OpenSense box.
Right
These
there.
are your clients. These are your servers, because that's what your PLCs talk to.
Right now, what we have is the 172.6.2 and the pfSense, and that's about what we are trying to get. We are getting right now, you added one more, so which would be the clients that are accessing it through through the network, everybody else can be everybody else. Those three lines are right there. You can add them. That's all.
We can certainly do that.
Absolutely. And as you were saying about the box, I just realized that having an i7 10th gen or more on a renewed or refurbished box that you can just buy off the market on a refurb or an e-cycle or e-based could plenty of things for the actual server. It can run 3-4 servers in there.
Oh yeah, and again, in this dev environment, it's chewing up way more resources than we need it to because we have GUIs. But once we filter it down, you could pull this off on some pretty reasonable hardware.
We were able to connect up to 25 to 30 users on just a gigabit local SAN.
Oh yeah.
Yeah, and I was like trying to see if it is a school-sized one, then it might need to 10 times that. So that's when we get like a gigabit network with a larger scope for that particular thing. That's why the box was a server. So server can take any many requests. So that's the best part of it. So we were trying to see if it is possible for, initially my thought process was a larger server, like a 720 or a 730. But then for practical purposes, you need to bring it down to that.
It's not fun carrying those around. I've actually had to do that, and I don't like it.
So yeah, this is actually cool. I wanted to first go through the Proxmox upgrades, and then get on with this monster alone. So right now I'm tackling it as a standalone box. So
perfect. Well, here's our two commands in order to get Podman up and going. So let's do that. And I'm just going to go back in and delete this little file I got. That's not what I meant to do. And so we can throw up a terminal, paste those in. All right. Cool. So it looks like we got our Podman desktop, and unfortunately it didn't give us an icon. I was really hoping to give us any little icon there, but we'll see what it goes in. And like I said, it's been forever since I've used Podman, so Podman appears to be working for that, but there should be a actual GUI that we can play with. So let's do some looking here. That looks good. We don't need development versions. Not going to build from source. Okay, so running Podman is basically like running the Docker command. You just add it in there. So instead of something like Docker blah 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 blah, you would just type Podman blah 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 blah, and that should get it up and going. So I'm going to see if we can't get a basic setup of everything going here.
Just remember that you're running Proxmox on a box, and it might be already taking resources.
Yeah, and thankfully these boxes are pretty beefy, so they won't have much issue there.
Yes.
So let's see. There again, I'm not overly familiar with Podman here, but we can see what we can pull up. All right, so that command basically is like Docker, right? If we look at what it did, it just fired off a basic one from Docker that's Nginx. It's literally all it did. And started running it on port 80.
Almost looks like a skin, that's all.
Yeah, it looks exactly like Docker. We just use the word Podman instead, right? But and so on this side, if we go to localhost and not HTTPS because we did it on 80. And it's trying to redirect. Actually, it's 8080, sorry. And again, not HTTPS. There we go. And so that little web server's up and running. When you run this, just know the number on the left is the one that you would actually access it from. The number on the right is the port inside that container that would normally be running. So you're doing basically port forwarding when you set this up. And so 80 is what Nginx would run on by itself. You're mapping that to 8080 on the outside of your host machine, like this guy here. So with this being a little Nginx one, that's cool and all. What we would want to do is something like podman ES, and that shows us all our running images. Again, this is interesting because this is all like the command line version of Docker, right? You're not really doing much different at this point. Thought it had a GUI, unless I missed that for the Linux side. Did I miss that? In other words, that's Pacman. Thought I saw a desktop for Linux, and maybe that was the one I downloaded and didn't get there. Let's try this again.
Docker has a daemon to manage the containers at a higher level, but Podman is rootless.
Yeah, so it's really much like Docker. What we're looking for, there is a desktop and it's a Flatpak. So let's pull that back down again, and then let's see. It'd be nice to, yeah, that makes sense. So it comes as a Flatpak file. We just have to install Flatpak. So we would do sudo apt install Flatpak. Great. Then we're just adding a Flatpak repository. Oops. I forget when I copy this inside here. I got to do it differently. That gets the repo in there. Okay. And then we can install the actual desktop client. And again, all this is the equivalent of Docker desktop kind of thing. Only, like you said, you can combine things into pods and do that kind of thing with Podman.
Goes to the logic of an OpenStack.
Yeah. Yep. The Kubernetes set is like a whole nother. I mean, there's Docker, and I've got my head somewhat wrapped around the Docker container side. And then there's Kubernetes, and I've played with it, but man, is it a whole different abstract thing. So
Podman is a middle ground between those two. It has a functional representation of both sides in terms that it kind of leans on Kubernetes in terms of implementation, but in terms of interaction, it's more like Docker.
gotcha. All right, let's kill that side. Yeah, might as well let it install its little kubectl. We won't use that right off the bat, but it might be something that you want to deploy for some purpose. And compose being compose files. Great. That we will use because at least that would match more of what I'm used to. Okay. So let's see if we can find that one that we already had up and running. And it did. That's our basic little web server that we have up there. And so pods, I'm assuming this is where we can create our first pod. and it's just a series of these VMs together. Does that sound about right? Or containers together?
Yep.
Okay. And I assume you are writing that in a fashion that's very much like compose files when you actually create that out.
If you create those, and you can actually have a, after you create a pod, you can have a little compose file that you can then edit into.
Okay, great. So the first thing we would want to do is let's get rid of this little basic guy. Great. And we want to run the equivalent of something for CTFD, right? So if we do a Docker file and we could point out to one, in our case, let's do existing image. And for that image, we want fine. Just want to make sure I get the syntax correct here. Yep, CTFD, CTFD. I thought that's what it was. We'll copy this whole thing for the time being, but we just want that inner piece. That one there, and we don't care about the version right now. We want it to pull the latest. And so all we really care about is that there. Okay, so that has to pull from the Docker hub. So let me get the whole command there. Let's see here. That would be like this. And instead of Nginx, we would have CTFD, CTFD. I believe that should get us what we're looking for. Nope, didn't like that one. In other words, I got the Docker command. I just have to figure out what repo it is so that we can marry it up with pod. Let's see here.
I'm trying to run the same thing in here.
Yeah, I'm trying to see how we would end up running that on Podman. It's going to be just a variant of the Docker one.
So it pulls from the same repository as well.
Not run the Docker Compose. I mean, the best one to run it on would be Docker Compose. I was hoping we could just use the smaller one for that, but well, we could do it that way too. So let's try containers. Create. Nope, it's not what I meant to do. Does this go here off of Docker Compose, or is that going to be an extension? And there we go. Using Podman Compose. All right. So you could pull it from Docker IO, but you got to use your login so that you have access to that repository or your local ones.
You can also get it from Git.
Okay. Let's see here. See if I can point it straight from there. Probably just have to build it from that section, which is fine too. It's got too many darn tabs over here. So since this is here, I'm going to go ahead and it won't let us pin it. Of course not. That's in it. Oh, I was missing the Docker IO part. Okay. Maybe there should have been something simpler. So we'll just, for saving our data and such, we would start out with creating a volume first. And so this volume we could just call CTFD data. This would be created if we did a compose file, but we're going to do it this way. And we have our CTF data. And then for pulling the image itself, we could do a pull. And that is the Docker IO, which is what I was just missing to go. CTFD, CTFD latest. That one there. And if we tell it to go to :latest, it'll pull the latest version. Like that. There we go. Like I said, I just had to learn some new commands. Sorry about that.
Every day.
All right, looks like it pulled our CTFD instance down. And so now we could go to our container, create one, existing image, and we can point to our CTFD. That looks like that's good. And we can go ahead and run that image. Then if we wanted to, we could change our names and such to it. So for now, we could do something like CTFD, leave all the basics in there. Volume-wise, we could point to the volume that we had already created for it. So if we click on that, oops, we don't want to mount that. We want to add the actual volume. That side, where is the volume there? And we could do whichever local port we would want that on. We would probably do something like 80 just to make it a little easier. They want us to do it with sudo. So we would have to do 8,000 for this part. We could do some port mapping stuff down the road to make that easier in our OpenSense box. Advanced. Does this not let us point to a container specifically? That would be an outside mount. We don't want that. Starting advanced. We're good on that side. Networking. There again, just letting it come inside. If we wanted to set a particular host name for the CTFD with the DNS type thing, we can do that. We'll just leave that alone. And that'll work for now. Let's see if that at least gets us a container up and going. Looks like at least started there. Okay. So now we can see it's running out there. If we go to a summary, looks like everything's good. Logs came up. Terminal, everything looks good there. So if all went well, we should be able to have, what was this thing's IP address? All right, 172.16.0.143. Now, obviously, we would probably want to set that as a static so that it wouldn't change as we go through here, but this will get us started. Did I say 143? Say that. Yeah. On an 8,000. And there we go. There's our CTFD running on our virtual machine ready to go. And because it's up and going there, if we actually come over here to our client, we should be able to pull up the browser. Again, have them go out to the same address, 172.16.0.143, on port 8,000. And they got access to the CTFD from the client side as well. Cool. It's a pretty good start.
This thing is much more GUI based, and that's what people find a little bit more comfy with if they are coming from a Windows environment.
Oh yeah. Yeah. And that's why I said you kind of have to do this to get it figured out. And then once you build your image, okay, yeah, now we can make it super tiny kind of thing. And the cool part, again, this is all self-hosted inside this little set of virtual machines. So on the outside, we just have our Proxmox system running 3 virtual machines, one acting as our router firewall for everything, the other 2, one being a server and one being a client at this point. And then we could add in bad virtual machines to go alongside our quote server out there if we wanted to, or we could have more containers spun up so that the students could access containers. So if we built some bad containers, etc., they could have access to it that way. And then, of course, you save this as your admin for your zip file and whatnot. And you export your zip file so that you have a backup copy. If you need to plug it into some other CTFD, you can do that. On this side, we could do that in such a way that we would have DNS, and because we control the DNS in this pod, we could make that work pretty easily. So for example, let's go back out to our firewall. Not like that. Okay. Let's see here under services and this DNS mask, we could do domains, and we could just create kind of our own little domain on this server. So let's call it, I don't know, ctf.io. Why not? And for the IP address, it'd be our 172. Let's see here. How would we want to set this up? So before we set that to 143 and do all that, why don't we take our server image and actually set that as a static so that we're not pulling DHCP on there anymore. For the sake of this, we'll just put 2 for now. Go. DNS, we'll leave it to pull. We actually will want to set this to the 172.16.0.1. Apply that. Too many there. Apply. Switch it off, switch it back on. And okay, so now we're 172.16.0.2 for the server. And then over here, well, let's look at our DHCP range that we had set up for these guys and edit that. And on the client side, we don't necessarily see a domain for that. What I'm looking for is, so I'll set up there. Server side, domain's now going to be ctf.io. That looks good. And we have our domain. Let's go ahead and add that back. sure. Yeah, we just wanted to actually pull from here. Not really going to override that side of it. That looks good. And on the host side, let's go ahead and add a host for this. You can just say server for CTF.io 172.16.02. That'll work. I'm trying to remember what the option was there. There we go. Name server. I think I got that set up right. Let's see. We should be able to test that if we pull this up. Do I think that's pulling what I want to pull. Oops. There we go. So DNS is now pulling from locally as opposed to going out to quad 8s, which it was by default. And if that's working, okay, we should be able to do oops. And it looks like it resolved it. So now on the clients, you can tell them just to go to server.ctf.io, and you're still going to have that 8,000 for the time being, but it should resolve up there. That may or may not work simply because of the G unicorn stuff that's running for CTFD. We may have to actually add that as a domain name so it knows how to respond there. But it looks like it should be resolving correctly. Except it's not. It's pulling out. Oh, it's because those are real and doing lookups out there. So we would probably want a better domain than something that's out there for real. So something like ctf.local would have been a better choice than ctf.io. We could go in and adjust those settings.
And this was one of the reasons I had set up a little switch and a router separately.
Yeah, and I mean, what you're doing there is the same thing that is here. I'm just trying to virtualize it as all.
Yes, yes. That would be easier for the students actually. I'll ask a team of people to actually set it up. One configures the router, the other manages the switch and the VLANs.
Mhm.
Consensus on another student, so we can have them do a team that they can go around and make presentations so that it's easier. The physical device choice was that way. And I get into OpenSense, it's just like digging treasure. So
Yeah, and this is the first time I've actually gone in and done this portion on here because I've used the older DNS stuff. I haven't used this DNS mask portion, at least the UI variant of it here.
GUI things are like another aesthetic or what is called as ASMR.
Yeah, exactly. Yeah, you give me a command line, I'll do DNS mask, but yeah, this one's a little touchy. But we can get it in here. It will work. All right, let's see if that fixed it. Just manually override it for the time being here. And what is server.ct? Figured I was missing one in here. So I got server IPs. There we go. Looks good. See anything I'd have to set up on that side. Yeah, no problem, Jim. Have a good day. Okay, let's see if that did any. No domain. Well, in theory, that's how we would set it up. I just have to go through here and figure out what I'm missing in the tweak and whatnot. But like I said, it'd be handy having this little firewall there, whether you do a physical one or you do this one inside. We could set up little DNS records and stuff to make it kind of act like a real network on the backside. All right. Obviously, this is all working just fine here.
Yep.
So, and then, like I said, we can do one of two things. If we found containers that we wanted to go light up and run on this network, well, then we just do that through Podman, right? We have one VM that's doing all the Docker stuff. And then
Yep.
if we wanted other VMs in this section, well, then we just put other VMs on the server network.
Mhm.
And that would make it easier for that. And then if you had a separate SCADA network, like you said before, we simply put those virtual machines off to that, add a leg off of the OpenSense to have access to the SCADA network, and kind of go from there.
This is actually very good foundational scaffolding for that thing. So
Good, good. Hopefully it was.
the box is actually running with the Proxmox now. So, but that I just wanted to make sure that the physical systems that are to be added to it are out. So maybe I'll have a couple of NICs going out, and that's one of the reasons why I mentioned VLANs when
Uh-huh.
initially talking about it. But then if the physical interfaces are there, then we can just move it. And that idea about making a physical interface with the PCIe pathway is actually fantastic. Actually, I should try that. Yeah. Because
Yeah,
we have USB Ethernet adapters that can actually work with that particular thing, especially with USB 3.
I
We
would
just want to make
imagine
sure that
there's
those
a
are physical systems that are going, and FC's interoperability is available for that.
Yep. I would imagine you could pass through your USB device, clear into the VM, or if like you had a PCIe slot and you wanted to put in a wireless adapter that way, then you could pass that through too. So I think the way that would work is if you come into, oh, let's see here, you would have to add, you could either do a USB device and directly map to that one if it was plugged in.
Yep, it could be USB, because one of the reasons why I was talking about this was while USB 3 does not have enough bandwidth for what is called as a GPU external, it does have enough bandwidth for a network external.
Gotcha. Yeah, so like here, I could pass through from this underlying hardware, this direct. So like this box has two Ethernets and then two 10 gig Ethernets. We could do the similar thing. Well, actually, it does have wireless. I forgot. Well, let's just find out if it works at this point. Can't hurt anything, right?
That's what the spec said. It was wireless AC, and BT was also available there.
Yeah, that was on the little B link, but I forgot my MSO1 actually has that too. Never used it with Wi-Fi, but Let's see. Trying to remember what chipset it was. Oh, yeah. Guess it does have a. Well, guess we'll go play with that.
It is, yeah.
I might be even more excited about what I was doing now. So to make that work, we do have to properly shut that guy down. You do have to be a little careful when you do like hardware and all that kind of stuff, because obviously if you back it up or save it or want to move it off to other hardware, you'll have to remap it. But it's not like it can't be done, obviously.
The remapping is making sure that the physical logical connection is the same for the virtualization.
Yeah, usually where you'll run into troubles, at least from the VMware days, is when you try to do like snapshots and things like that to save your point in time, it can cause a little bit of problem getting that set up, but we'll
Okay.
see if that ends up being the case here. So the reason I wanted to pass the physical device into here is so that it could actually put that device into AP mode and actually control the wireless device. If you just pass it through as a network, then it doesn't do you any good. It needs to be able to see the actual device. So that came up. Let's see. Password. Well, let's come in through the client side and see if because if it works on here, then it'll clearly work on that other little box too. Okay, wireless devices. Okay, I wondered if it was going to be a driver issue. So, now you got me gonna attention here. There it is. Is definitely how it would work. It's just we got to get that driver to be found. So let's do this. I want an 8.
I was trying to add some devices to the server to do something else, like mimicking an actual red team setup using a Proxmox box. That's where I encountered the physical device thing. So this is good.
Gotcha. Let's see here. I'm wondering, even though I passed that device through, if I actually have that enabled on my MSO1 and BIOS, I don't remember if I shut those off or not. And the fact it's MediaTek and not something that's a little more name brand.
We wanted to see if it was accessible through a through an image or get into a client and then see if it is accessible from there.
Yep, that's the one I passed through. Um, smart. Aha. So for most compatibility, it wants me to run a different machine type. So let's see if that helps. I would imagine it's still a driver thing because it's a cheapo wireless card in that thing.
Generic MediaTek driver. If we change
Yeah,
it,
if I threw like an Intel one in there, it'd probably pop right up kind of thing. Which I think I have one at the house actually.
we were trying to use this to actually create what is called as a virtual device towards sensors. Remember, the SCADA network is wired network, fine. But there are sensor networks that can be wireless, and we could have these as these virtual machines could be virtual servers that are getting signals, MQTT or RF, depending upon where the sensors are. They could be for a building or a local unit or a facility.
Yeah, you could absolutely type.
Mimic temperature control or sensor control for a data center. That's why I was like trying to see if this was possible for doing that. Otherwise, we'll have to. That's another reason why there was a switch. Plug
Yeah, right. Nope.
it out there. Yeah. So
Totally makes sense. Yeah, that would allow us to find it. I bet it's simply because it just didn't find it as a driver. Okay, let's try this. Root password. Heat. Right. Okay, so there's the MediaTek driver. So I found it. Let's see here. So I want to make one little slight tweak to our image here. So I can copy and paste commands at its command line there. All right, let's try that. And then do what it's supposed to do. Didn't. No. There we go. That's better. So that little tweak, all it did was allow me to use more of a terminal port where I can right click and paste and do that stuff. When it's in a VNC to a console, you really can't do any of that. It's kind of handy if you are using like a Ubuntu server and nothing with an actual GUI. You can do that same thing. You just come to your display, set it to terminal 0, and then add yourself a serial port 0. And so it turns that. It's like consoling into a router or switch from Cisco. Same idea. This gives you the equivalent of like a PuTTY terminal window. Now, if it boots, we'll make sure everything boots, but I may actually not see the rest of this screen if it goes into a VNC console. Yeah, we might actually have lost that part of it when I did that. Too many changes. Or I get crazy and do a bunch of weird side loading of drivers. And that's part of the problem here. I said that earlier. OpenSense, pfSense, those, they're all FreeBSD based, which is a little more complicated because drivers and stuff don't always get updated or used or any of that kind of stuff in these particular distros. But let's see if it's not a UI thing that's available that I missed. All right, system firmware updates. All right, so plugins, a couple of these would be handy. There was, it's VMware Tools. I at least wanted to get some of the other ones. So let's do settings, check for updates. bring it up to date and see if there isn't a plugin for extra packages. I think there was, but still sharing. Okay, sure. All right, let's see on the plugin side. Packages. Since I'm here, before I forget, was it? Oh, yeah, it's got guest utils. Okay, great. Well, let's see if we can find that driver again. So I wanted here, show. That was a 7922. Okay. See how to download that module. Okay. So yeah, it turns out it doesn't support a whole lot of fancy Wi-Fi stuff. So can it do it? Yeah, sure. Um, but even if we go through the habit or thing to get it to work, it only supports like Wi-Fi 4.
Yep, that's kind of what I suspected. That's one of the reasons why it was like, let's get this out to a different device and then bring the device onto the well-known Ethernet.
Yep.
But this is actually great. Good learning, experimentation.
Yeah, it's at least good to rule it out, right? Because otherwise it would have been handy to have one small little box that handled it all.
Maybe I should just add a little pie on the side.
Yeah, you could. I mean, it's just another device to make it go through there.
And that would be the GPIO, or make an Arduino or a Pi to go to this to the IoT part of it, so that we can connect that to Wi-Fi devices as well. It's easier to manage that way as a separate device.
Yeah. So with what we've got going on here, what was the next step that you guys wanted to do? So we at least got this environment up. We got CTFD to a spot where you guys know how to go build stuff with it. Anything else you can think of that we would want to try to build out? We got about an hour left today. And so tomorrow, the plan, from my perspective, would be in the morning. We obviously do a quick review of everything that we've done, so that we can have a quote assessment at some point tomorrow. And then the rest of it is me getting you all these files. That's kind of when I wanted to treat tomorrow, as making sure everybody has access to all the materials and everything that we covered today. So if that means me getting the website up during that time, or whatever else you guys were interested in, we can keep working on this side of it. I don't have a problem with that. Again, like I showed you here, for example, we would get you connected to a PBS, and then you could come out here and grab the Ubuntu desktop Docker image that we just created here. You would be able to hit restore off your Proxmox and pull it straight in. I'll have that all stood up here tomorrow while we're doing that as well. You can at least get these 3 images, even if you're going to obviously need to make some tweaks and stuff to them. But I have copies of those before we did a lot of the configuration, so you could start with the fresh ones and then watch the video to set it up for the environment you would want. Robbie, any thoughts of what else you would like to get done with this setup?
There are 3 things I would like to do. One of them is that I'll take this setup. I'm going to have 3 variations of it tried out. One, as we discussed right now, this is going into a box with the virtual setup completely with Proxmox on it. So that will be a self-contained box on it. But then that means that everything is virtual. So that goes to the physical systems part is a little bit less covered on it, but it's virtualized. So this would be a scaffolding for it. So wanted to see if it is possible for us to add a virtual machine or a virtual image that can act as a conduit towards physical devices. Because right now we are constrained by the physical device that we are stored in, which is a hypervisor. Technically, it's a Proxmox server, so it's virtualizing it. But wanted to see if it is conduitable towards what is called as we have the CTFD running on one side. That's one machine. That's fantastic. But would we be able to provide a dashboard of data coming from sensor devices?
Yeah, so that would be more like the FUXA, right? So
Yes.
on the SCADA one, we would just have a VM that would be able to run FUXA, and then you could point physical PLCs or anything speaking Modbus basically up to it.
That's I wanted to see if that's maybe that's something that needs to be fleshed out as we implement it in the field or try a little expansion. But wanted you to give a little pep on where would we place it if we place it in that sense? Would we be placing it as an exclusive separate device, or would it be a start of a virtual appliance here itself so that it can sense everything up like a server setup in there? So yeah.
Yeah, so more than likely, this server Docker stuff right now is just to host CTFD and that kind of stuff. Nope, no problem, Wendy. And so this probably isn't going to be the same network as your SCADA, and your PLCs are going to be all on the SCADA network. So we would probably want to create this extra leg for a SCADA network.
So second box might be a good idea to actually have a GPIO. The box in the sense of PI or a GPIO that would be more towards going towards the sensors.
Yeah, you could do that. So like here, you could do a virtual machine that runs the quote unquote SCADA.
Yep.
And so like in our case, that was FUXA, which was also SCADA/HMI, and then a network that just tiers off to plug into a physical device of some sort.
Yep. That's what I was like trying to get on that side of things, so that when you look at a physical box, it will be an Optiplex box in there that's running an appliance that's beefier. The server Docker, the OpenSense, everything runs on there with the ports. But then I wanted to add an add-on box or a hat or something that's like a Pi or an SBC, single board computer or something that can actually act as a conduit towards physical devices, like probably 3-door sensors to the server room, maybe a little motion sensor or relay that allows for temperature, other sensors, so that if there is an ambient change in there, it could be a physical hacking scenario as well, so that we can test that in that particular service as well. Somebody is doing a physical hack and somebody is trying to enter it, and all data is going to the server that stores it, and that would be also a physical metric or a dashboard that is available for us to see.
Yeah. What I'm trying to think of is, like I said, we could easily set up a VM here that's running Fuxa for that to be our UI. We can do that in a way that is really lightweight. And so, yes, that would be a VM that sits on this SCADA network. And
Mhm.
then, like you said, whether we use a Raspberry Pi
Mhm.
um, to act like a PLC,
Uh-huh.
but we would need to potentially connect to its GPIOs and make it speak Modbus out. That's the part that could be
Challenge.
tricky, but possible.
Yep.
On
I
your Raspberry Pi that you have available, what kind of sensors do you have today?
Generally, we have sensors that are like temperature sensors, audio sensors, video sensors, motion sensors, light sensors. We have a we have a water level sensor. We have um, tracking sensors, which are like more like they're actuated by time or they're actuated by motion, or some of them are like just time counters. That's all.
Okay.
We also have um, these are all me doing the personal side projects as a faculty there. That's about how it is. So we do have solar tracking sensors.
Okay.
We built one that tracks the sun and that's charging setup. So that when it moves, we can add that to that network so that when it is a farm or a cluster of sensors, then we can actually coordinate, cluster them. And if they are, we can see if this is a vulnerable one that it is physically hacked into.
Okay.
So the long story short is that yes, I'm working with the sensors, but the point is that we'll have one box, the network goes on. I would like to add a second smaller box or a Uno or a Pi towards having the physical systems out as well as an option. That's all. That's just that's the third variant. That's all I'm saying.
Okay.
Yeah, that's the try. That's the original idea. It's still not fleshed out in that sense, but I would like everything to be contained within that particular logical setup of a 16-pound box that can be carried around anywhere you want.
Oh, what I'm trying to think of is what I could demo to make that work.
You actually answered the question and partially actually did the actual thing even before starting. This is a FUXA server because original concept was about IoT. So my thought process now is trying a FUXA server and implementing it into a virtual machine and then running it and then conduiting it to the actual physical sensors data.
Gotcha.
So that would be if it has all the drivers. For example, we had the physical driver challenge for the wireless part of it. So if some of them are RF sensors, then it would be easier for a different platform to receive it and then channelize it through a data stream towards coming to the server that can then take it and just display it.
Okay. So in the little time that we were playing here, I think based off what I have available here and what I could pull off,
Yeah.
I think I have a Raspberry Pi in the other room. I can get it ready and get it set up. And I can write a simple Python script upon boot up that it will pretend to be a PLC. It's just gonna speak Modbus TCP, pull in from whatever on that sensor, and send it back over Modbus protocol. And then we should be able to build a SCADA that HMI on this side and actually let it listen. And if that works, then I can actually just send you the Raspberry Pi image.
Yes, that would be fantastic. That would be actually fantastic. I'm just trying to see if we can implement it with the Nano because we got a Pi grant, so we have about 25 Pi sitting there. We
Okay.
are using them for our hardware IT essentials, but then this would be fantastically more useful for them to
Yeah.
actually build this one and actually do IoT in there. So
Okay. How about everybody else? Does that sound like something that would be useful? Because in the classroom, at that point, there again, you just have a simple Raspberry Pi. I give you a script. You hook up a simple sensor to it, and that Raspberry Pi will act like a PLC speaking Modbus that you guys could have this VM here running HMI, and now all of a sudden you have this OT environment to teach things in. As a matter of fact, when it works on this client over here, you could run MBT, MBT get like what we did before for Modbus, and we could pull that sensor on the client And then obviously we could build that eventually into a CTF. But the CTF for now could be like a question stuff to get them to log into these different PLCs. And then because you're running that as a physical device down here, it would all work. If you wanted to emulate some devices down here, we would use the same script, just running on a Ubuntu server image, really lightweight, and kind of giving fake temperature information. Like we could write a script that makes it vary and stuff. So then when we look at it in the HMI, it looks like it's a PLC listening as well. So we could have two things. We could have a real Raspberry Pi acting like a PLC, and then we could also have a virtual box kind of thing acting like it's a PLC. That cool? I actually like it. It sounds like a fun idea. Okay. Awesome. So hopefully that gives you guys some materials tomorrow by the end of the day that you can literally implement in the classroom. I'm pretty sure I can pull off this Raspberry Pi piece of it. And then of course it's just going to be a simple image. When I get done, I'll image that Raspberry Pi so that it's available for you guys to burn with Raspberry Imager, and then you can just image it straight to it and go from there. Cool. I will see what kind of sensors I have available. And then we could hook them up through the GPIOs. I'll run off a different move there over there. Yeah, I've got one here, JB, on how to pull that up. We should be good to go. What I have to find is my Raspberry Pis, and I have to find my sensors. Pi Model 3B. No, in this case, I don't think it's going to matter because we're not really doing anything heavy lifting, Chola. So it should be okay with anything. As a matter of fact, I'm pretty sure the ones I have down the hallway here are going to be even Raspberry Pi 2s, possibly, maybe 3. I don't remember what I got in the closet down here. Tell you what, I'll be right back. I'll find out. All right, sorry about the silence there, but I was able to find a Raspberry Pi 3B Plus, so it should match exactly what you have, Chola. Was trying to make sure I had a SD card. Looks like I'm good there. And I just got a Raspberry Pi with a breakout cable and a breadboard. Now I just trying to see what kind of sensor I can find for everybody. RFID isn't exactly what we're after, but let's see here. That's what I've. It's hard because I don't have so many sensors. I let so many students play with these that I haven't had a bunch of sensors left over. Now that we use those Circuit Python boards, they've got all the sensors and stuff built into them, so we didn't have to have a bunch of sensors around here.
We had retired our old camera and the VLAN networks that were sensors, that were having a lot of sensors. So we just inherited the switch along with all the Ethernet connections up there. So
There you go. That's what I used to do all these Raspberry Pi camps, and I it seems everything's gone now.
now, yeah, takers are there for a lot of these things, and especially when we send it out to surplusing, it goes central through the state. So before going that, we get dibs on getting all the stuff that we can scrooge for the students to use it for hacking out.
All right, so it turns out of the only sensor I can find is going to be this ultrasonic sonar distance sensor, which turns out would be pretty darn relevant to what we're doing. So this would be not the best sensor, but a form of a water tank sensor, right? As it got closer to the top, we would determine that's full. When it's further away, we could get those numbers.
This could also be a security motion sensor in front of a door.
Yeah, exactly. Like the idea here is this will actually tell us distance based off sonar. So what's cool is I think with a little bit of work in Fuxa, we could literally create like a tank distance thing so that if it got so far away, we could test the distance.
Fantastic.
Something if that works right up the world of what you guys are thinking here.
It opens up the whole gateway for everything else that we can add into it.
Yeah. I mean, obviously, you just replace this with some other sensor, but I think if I can understand, this is 5 volt. I'm trying to remember now on Raspberry Pi. Are those 3 or 5?
They have both.
Okay.
5B3 Plus, it has both 3 and 5.
Okay, great. And
It's the Pico and the Nano that get like a 3 volts or down, but the Pi is actually a full powered one that has 5 volts and 3 volts. That's what we use for our fans. If you're using a fan for the dissipation of the heat in there, if an external fan is there, we use the 3.3 and the 5 for different speeds. That's possible.
Okay, good.
Yeah, yes.
So, because if I'm reading this right, we can either make it speak its own mode, or we can also make it speak based off serial, which for us shouldn't matter. So we just need 5 volt. Let's see, trigger to initiate the ultrasonic burst. Okay, I think we can do that with a simple GPIO. Echo return signal. Sensor comes with 2K, 210K resistors. Yeah, sure, they do. Somewhere. I'll find them. I got a stack of resistors. That I should be able to do. Define the difference. So this should work. Let's see here. I think we should be able to make this work. Yep, we'll use GPIO pins 23, 24. Ground, and yes, I can make this work like Modbus. Okay, cool.
Yep. Pins 1 and 2 are the 3.3 and the 5 volts of them. Oh.
Perfect. And in this case, because I have it going out on registers 0 and that kind of stuff. Yeah, I don't see why we couldn't have this up and running and I'm making it act like a PLC. That's kind of cool. Makes me want to write a bunch of other scripts when we get it working because it's a cheap way to make it a PLC and the system doesn't know any difference, right? It's just speaking Modbus. That's all we need it to do. If I get crazy, I'll see if I can't get my little click PLC also in there as just as a quote real PLC, but
Sure.
this is obviously way more approachable, right? For most people, they have Raspberry Pis laying around. All right. So for the sake of ease, I'm going to take our Docker desktop one we already had, and we're just going to create and call this our SCADA HMI. That'll work. And hardware-wise, let's see here. Do I have any ideas on OT security exercises around the Pi project? Yeah, Chola, we'll definitely try to come up with something tomorrow in terms of ways to pull stuff about that. Yeah, exactly, Risa. So I think once we get the initial Raspberry Pi up and running, that we can have it sending data out of the ports, real live data kind of thing, then I think we can write it in such a way that we could feed it information. It'd be very similar to what we did the first 2 days. Like we could obviously do where we're overwriting the values and stuff if they were able to break in and pivot into this network. It'd be very, very similar to what we did for the labs in the first 2 weeks, but we'll see if there's not a better way to do it. For test purposes, what would be nice is figuring out while it's speaking Modbus, see if we can't make it do secure Modbus, which is a thing, but very rare. And if that's the case, then great, we could get it to pull up. Or would they be more secure in moving from Modbus to say ENIP or another protocol that has a little better security around it? And we'll see if we can't write another script that would speak that language. Remember, our HMI, FUXA, will take all of those for the most part, all the ones we talked about. So all we have to do is write different scripts, one that would run Modbus, one that would run another one, and then we could see if we can make it more secure as opposed to the least secure. At least that's what's noodling in my head here, but it is 5 o'clock at the end of the day, so it feels like mush. Let's see, HMI. Let's go ahead and create on this guy. We'll just create that other network we were talking about. So let's do SCADA. And so for that SCADA network, I'm going to do a slightly different thing. I'm going to delete that guy. Remove because, well, no, I don't. That would be fine. I have another Ethernet port, so I'm just going to use it as a bridge. That'll work. And then that bridge is going to be ENP2 SO. And so the difference on this bridge that I set up is that we're going to allow the Raspberry Pi to directly connect to the Ethernet port off of this this system on that particular network piece, and that will allow it to communicate with the Raspberry Pi. If I didn't have enough ports on this machine, then we could easily do VLANs or something like that to make that work.
Oh, yeah. That's why I was like even thinking about that in the original, topology.
Yeah. And there again, it all depends on what hardware you're running, how many Ethernet ports you have, that kind of stuff to help break it up. Okay. So I've got my SCADA network. It's passing through on that. And then let's see, we built our SCADA HMI. we'll just change our Ethernet to go to the SCADAnet, and we will make sure that it will be connected. For now, I'm going to leave it disconnected because we're going to add another device to the internet. And I'll get this up, and then I'll have to tweak my OpenSense box to be able to route traffic off that side as well. But for now, I just want to get this thing up so that we can get Fuxa up and going, because that took a little bit, if I recall, back in the day. Oops, that was Spice. And again, I'm going to run it on a Ubuntu desktop machine because we already have the image, the base image. You could very well do this off a server machine to save resources. Because I would assume this is starting to add up. Like, we gave this 4 gig. I could probably scale this back down to 2. If we got rid of the GUI, I could probably bring it down quite a bit.
16 gigs in there, but that's the point. We have many boxes that run 64 gigs right now, so it's okay.
Okay.
That's a good starter. We have a balance of 6 gigs on the whole entirety of it.
Yeah, yeah. And again, we can rewrite this to be a very lightweight VM when we're done. Let's see. So I got to remember, should have an IP on the management network now. Yep. And so let's go look up. I remember it not being too terribly difficult, but we did have to have some. Aha, they have it as a Docker container. How handy. Because we're going to create this lightweight VM, we probably won't run it as a Docker container, but the fact they have that option now is pretty sweet, because then we could have it communicate out.
Next time, try to run this Docker container inside a Pi.
Yeah, there you go. Yeah, so you could run it on the Pi and see how well it would go. Let's see here. I'm going to do it from NPM, because that just runs the local one, basically like the way you did it in the lab. So let me see. Actually, it wouldn't matter if we did run it as a container, even on this machine, because that would actually be something we could have start automatically and whatnot. So all we got to do is install Docker. And so installing Docker directly on like Ubuntu and stuff like that, the links out there off my deal of links. You can just kind of follow along right with what they got. That's what I'm doing here. Just going to remove any excess packages that would have issues. Rid of some prereqs. Great. And the actual Docker stuff itself. Whoops. Not that one. Again, this is even how I'd run it as a lightweight one. We could use a real lightweight server image with Docker installed, and then it just runs this little container in the background. Keeps us from having to have NPM installed and having to set up a bunch of other stuff. We could just make it run the container automatically. Here, 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 here. the end of the day, for our purposes, all we care about is just something running the HMI SCADA side. So, all right, since we found that, let's pull this back up here. And let's have it run with persistent tags and all that, because then it would be everything set up that way. We're actually going to run this hopefully on port 80, because I don't necessarily want to have students go to a specific port, and that's pretty much all that's going to run on this little SCADA system. Yeah, that's what I was afraid of. It needs privileged mode, so we're just gonna give it a sudo. Okay. Here's that's up and going. And if we do our Docker PS, it looks like our container's up and going on port 80. Thus, if we come here to localhost, there's our FUX image ready to roll. Okay, so we at least got that up and going. Then at that point, we would come in and set up our connection like what you guys did in the lab. So that's our server. We would obviously want to create our Modbus connection. So we would say this would be our RPi for now or something. And we would want Modbus TCP. We want to poll every, I think the last time I did it was every second. And TCP. And then we would set up whatever IP on this SCADA network that maps over to what we're going to end up doing with the Raspberry Pi. So looks like we should be able to get that all to work. The hardest part is going to be this, designing the HMI to make it look like something fun. So. All right, I'm going to go ahead and end the recording here for today.